Hello everyone, welcome back to this channel. Today we are going to discuss some MCQ questions from statistics. Okay, so let's start. Our first question is a matrix used to display the frequency distribution of two or more categorical variables. So you have to tell the name of the matrix and these are the options: crosstab, Pareto chart, histogram, pie chart, bar chart, scatter plot. Okay, so three things you have to understand. First, this will be a matrix. Second, it will show frequency distribution. Third, for categorical variables. So tell me, what is a scatter plot? Scatter plot looks like this, right? It is used to represent the numerical values. So this is not the answer. What about bar chart? Bar chart looks like this for categorical variables, but this is not a matrix. So this is also not an answer. Pie chart looks like this, right? And in percentage format. So this is also not an answer. What about histogram? Histogram looks like this. It looks like bar chart, but there is no difference. In bar chart, there is a difference, but in histogram, the boundaries are connected to each other, and it is also not a matrix. Pareto chart also looks like histogram or bar chart, but there is a difference. That is, it is in descending order. First the data is sorted, then this is plotted. Okay, so this is also not a matrix. So the answer is crosstab. Okay, and crosstab is also known as two-way table. This is a matrix. Let's say I have a data where some males are preferring tea, some males are preferring coffee. So I want to display my data in this way. I want to see how many male are preferring tea, let's say 20, how many preferring coffee, 30, how many female preferring tea, let's say 15, how many female preferring coffee, let's say 45. Okay, so you can see this is a matrix format, right? And these are categorical variables, right? And this is calculating the frequency of this variable, right? So this is what is two-way table or crosstab. Let me show you the code ones. See here, this is a data set I have created and this is the data frame. Just let me show you the data frame once. See, now I have represented this frequency in this crosstab format. Okay, you can see this one, and here you have to use this crosstab function. Clear? So if you want to present this in a matrix format, you want to show the frequency and these are the categorical variables, then you can select crosstab to show your data. Clear? Now let's move to the next question. Before that, let me just clean the things. Fine. Now, a type of histogram in which categories are plotted in descending order of the magnitude of their frequency. Okay, so I just want to say a type of histogram in which categories are plotted in descending order. So in this way of the magnitude of their frequency. Okay, so you have to first sort the data. You have to first calculate the frequency. Then only you can plot. This one I have just told you, this is nothing but Pareto chart. Okay, so it will look like this. Let me show you the code. See, here I have created a data set. This is the data frame. First I have sorted the values, then cumulative percentage is calculated and now it is plotted. Okay, and there is no function, direct function like Pareto chart, but in this way you can plot the Pareto chart. So for this you can see that these are the graphs, these are the bar. So you have to use bar function and then you can simply use the plot function. Okay, so then this will be shown in descending order and this is a line of their cumulative percentage. Fine, this is called as Pareto chart. Fine. Now the next question. To be used to evaluate two categorical variables at the same time. I have already discussed this. Two categorical variables at the same time. That is two-way table. Right? This one. Categorical variables. So our answer is two-way table or crosstab. Whatever your option is. Next question. A vertical bar chart in which rectangular bars are constructed at the boundaries of each class interval. That's also I have told you. Rectangular bars. So it will look like this. At the boundaries of each class interval. No difference. Right? In this way. Vertical bar chart. Simply you can say this is histogram. Right? Let me just show you once. This one. See, there is no difference at the boundaries. For numerical data, you use histogram, right? So you just have to use HIST, that is hist. This means please draw the histogram. Clear? Now next question. A chart should be used when you are primarily concerned with the percentage of total in each category. See, that means it will look like this. This percentage, you have to show the percentage, you have to show the percentage in this way. This one is simply pie chart. Let me just show you. See this one. Here we have apple, banana, cherries, dates, and you have to tell how much percentage of the fruit distribution is dates. So you can say 20%, right? So to show in this percentage format, you have to use pie chart. Hello everyone, welcome back to this channel. So let's continue our MCQ series on statistics, and we are doing questions from charts and graphs. Okay, so let's start our first question. A chart that should be used when you are primarily concerned with comparing the percentages in different categories. So you have to plot different categories and you have to compare their percentages. So in last class, if you remember, I told you that in Pareto chart, we plot bars in descending manner, and after sorting the data, we plot them, and then we also draw a line for calculating cumulative percentage. Okay, so you have to compare the percentage of different categories. So the best one is Pareto chart. Okay, so now let me show you one example. See here. Different types of customer complaints. Late delivery, damaged product, wrong item. Data frame is created, and now first you have to sort the values in descending order, and then you are calculating the cumulative percentage. Right? So after that you are just simply doing the plot. And for Pareto chart, I told you that there is no function directly. You have to use bar chart, and then you have to plot this line. So see, this is for late delivery, for damaged product, different types, and you can see that they are in descending order, and after that the cumulative is also calculated. So you can compare the cumulative percentages, you can compare the percentages of different categories. Clear? Now you understand why Pareto chart is most suitable. Fine, now let's do the second one. You want to analyze the trend of monthly sales revenue over the past year for your company. So you have to give monthly sales like January, February, March in this way. January, February, March, April, May in this way. So which one is better? So you can understand that if you just connect them by line, then you will be able to understand that it has increased in February but decreased in March, increased in April but decreased in May. Okay, so the best suitable is line chart. Fine. Let me just show you one example. See here, the months, different months and different sales revenue. If you plot the line chart, for that you just have to write PLOT. PLOT means that it will be plotted as a line. Every point will be connected by a straight line. So you can understand what is the monthly sales revenue trend. Clear? Now let's do the next one. You want to compare the total sales of different products in your store during the last quarter. You have to compare total sales of different products. So it may be laptop, it may be mobile. These are categories. And you have to calculate what is the total sale for laptop, what is the total sale for mobile, what is the total sale for tablet. Okay, so you have to compare the total sales of different products, or we can say different categories. So you can understand this is best by bar plot. Let me show you. See here, product A, product B, product C, and these are the total sales. So if you write bar product, you can understand for product A, this is the amount of sales, 150. For product B, the amount of sales is 200. For product C, it is 125. Clear? So bar chart represents this best. Next one. You have collected data on the ages of participants in a survey and you want to understand the distribution of their ages. Okay, so you have, let's say, 10, 20, 30, 35, 45 different types of ages. They have participated in the survey, and you want to know how many people are in the age group of 10 to 20, how many people are in the age group of 20 to 30, how many people are in the age group of 30 to 40. So what do, you create different bins. They are from 10 to 20, maybe 15 people are from 10 to 20 group, 20 to 30, maybe 20 people are in 20 to 30 group, 30 to 40, maybe 10 people are from in 30 to 40 group. Okay, so you want to understand the distribution of their ages. So best one is histogram. This is a numerical data. You are creating bins, boundaries are connected. Okay, and you find their distribution. So best suitable is histogram. Clear? Let me show you the example. See, this one is histogram. Different ages, and you have to just write hist, then it will create the histogram. And see, here they have given 6 bins, number of bins 1, 2, 3, 4, 5, 6, and you can understand what is their age distribution. Clear? Now let's do the next one. A chart should be used when you are studying a pattern between two numerical variables. That means what happened? That means here let's say some numerical number, and here also you have some numerical digit. It's like y equal to x square plus 2. So this will also be a numerical digit. It will also be x is also a numerical, y is also a numerical. So you want to see what is their relationship. So you just plot in this way. This is known as scatter. Okay, it helps you to tell what is the relation, whether it is positive correlation or it is negative correlation. For that you create scatter plot. Okay, when both of them are numerical and you want to understand their pattern, you go for scatter plot. Let me show you an example of a scatter plot. See, it looks like this one. This is also numerical values. X equal to some random number generated, numerical number, and y equal to an equation. Okay, and you can see that they are positively correlated. Fine. Hello everyone, welcome back to this channel. So let's continue our statistics MCQ series. And our first question for the day. You want to visualize the proportion of market share held by different smartphone brands. That means you have to tell Samsung what is the percentage or in what proportion, and Nokia percentage, Oppo percentage, Apple percentage. Simply you can say that pie chart will help you to do that. Let's say for Samsung, for Nokia. Okay, so for proportion, you better choice is pie chart. Okay, you know how pie chart looks. I showed you earlier also. Let me see. This is best to show the distribution, proportion. Fine. Let's do the next question. A chart should be used to study the distribution of a numerical variable. So here you will have a numerical variable. Maybe how many people are in 0 to 10 years of age gap, or how many people have got 80 to 85 marks. Okay, so this is a numerical number and you want to know their distribution, right? So this is best suitable for histogram. Fine, let me show you one histogram. See this one. Here you can see this is a numerical number and this is the frequency. That means they are distribution. Fine. Third question. You want to show the relationship between advertising budget and sales revenue. See, that means you have to show sales revenue here and advertising budget. So this is also a numerical quantity. This is also a numerical quantity. So let's say for this much of advertising budget, this will be the sales revenue. For this amount, this will be the sales revenue. So both numerical number. So when both of them are numerical and you want to show them as a scatter plot, right? Just let me show you. See this one. Here also you can see this is a numerical number. This is also a numerical number. This is advertising budget. This is sales revenue. So you can find their relationship, right? Like it is positively correlated. So scatter plot is best. Now let's do the next one. you have exam scores of students and want to identify their spread, median, possible outliers. See, this one is done by box plot. Box plot helps you to find which is the mean, which is the median value, lower quartile, upper quartile, what is the maximum value and what is the minimum value. And if any value is existing outside of minimum value and maximum value, then they are called as outliers. Okay. So to identify spread, median, possible outliers, the best one is, the option is not written here, sorry, box plot. Okay, let me show you one box plot. See, box plot looks like this one. This is the minimum value, this is first quartile, this is the third quartile, and this value is mean value and median value. Okay, so just you have to write box plot. That will help you to draw the box plot. Okay, clear? Now let's do the next one. You want to display the proportion of different causes of customer complaints in your service center. Same proportion, different type of customer complaint. Maybe late delivery, maybe package missed, whatever the reason is, you can calculate their portion in this way. So best is pie chart. Next one. You are analyzing the monthly expense of 5 departments in your organization and you want to compare their total spending. 5 departments. Let's say HR, finance, marketing. So departments, and you want to compare their total spending. So what is the spending for HR? What is the spending for finance? What is the spending for marketing? See, this is categorical. Sorry, this is categorical. And here you have to write numerical. So when you want to show the distribution of any categorical variable, which one is best? That is bar chart. Okay. So let's continue our statistics MCQ series. Our first question for the day. Calculate 5 number summary. 3, 4, 5, 6, 7, 8, 9. This is the dataset. The dataset is already sorted. If the dataset is not sorted, then you have to first sort the data. Then you have to find this value. Minimum, quartile, first quartile, median, third quartile, maximum. These are known as 5 number summary. Okay. So what is the minimum value from this dataset? You can easily say 3. What is the maximum value? 9. What is the median? Median means the middle value. What is the middle value here? See, 6 is the middle value because 3, 4, 5 and 7, 8, 9. Right? Now what is the first quartile? First quartile means all those values before 6, 3, 4, 5. Now you have to fetch the median of this. So 4. 8 is the third quartile. Clear? So this is also known as 25 percentile. And this is also known as 75 percentile. And what does it mean? 25 percentile, 75 percentile. 75 percentile means 75% of the values in the dataset fall below 8. Same, 25% of the values in the dataset fall below 4. That is why it is 25th percentile. Okay. And median is also known as 50 percentile. That means 50% of the values in the dataset fall below 6. Clear? So you understand the spread of the dataset. And if I ask you which chart or graph will you use to represent this, then you can say that it is box plot. If you have seen the last class, you know how to draw the box plot. Let me just show you once again. This is how box plot is shown. Here it is median, this is first quartile, this is third quartile, this is the maximum value and this is the minimum value, and if values lying here or here, then you can call them outliers. So to understand the spread, the median, whether any outliers in the data set, you choose box plot and that will give you this 5 number summary. Fine. Now tell me this question. If Q1 is 25, Q3 is 75, what is IQR? See, this is Q1, this is 25. This is Q3, this is 75. What is IQR? IQR means inter-quartile range. From the name you can understand that you are calculating what is the range of this interquartile. So the range is 75 minus 25. that is 50. Okay, so you understand the whole concept. Okay, now the next question. In a right skewed distribution, mean is greater than median, median is greater than mean, median is equal to mean. First tell me what is mean, what is median. Mean means for any data set, let's say 2, 4, 5, 9, 10. What will be the mean value? Mean is 2 plus 4 plus 5 plus 9 plus 10 divided by 1, 2, 3, 4, 5. So it will be 6, 11, 20, 30. So it will be 6. Okay. What is the median value? Median value is the middle value. This is the middle value, right? So median is 5 but mean is 6. So in some scenario you will get mean is equal to median, sometimes mean greater than median and mean less than median. But why? Let's say in your data set your data distribution is like this only. Then what will happen? Then your average and your middle value will be same. So it will be mean equals to median, right? This is called symmetric. Here the data distribution is almost equal in both the cases, but you will not get this. But in some cases your data set may look like this, right? And in some scenario your data set may look exactly opposite like this. Okay, sorry for the drawing, but you can understand that here this is skewed, right? This is not. Let me show you in Google. Left skewed distribution graph looks like this, right? This one you can understand, right side is skewed, so we can write this as right skewed, and this side left skewed. Data distribution is not equal, that is why the graph is like that. So here you can say that if this is median, your mean value will lie somewhere here. So your average value, that is mean value, greater than median value. But in case of left distribution, your median, let's say this one, but your mean value will lie somewhere here. So here mean is less than median. Okay. This is because of your distribution of the data. That you have to first make this data set normal. You have to try to make it normal data set so that it looks like this one. Then only you can apply some algorithms. Otherwise it will give you some skewed result. Okay. So and there are many techniques to do this thing. Please write in the comment section if you remember. So you understand what is left skewed and right skewed. Okay. Now let's solve the question. In right skewed distribution, mean is greater than median. Median is greater than mean. Which one? See here. Mean is greater than median. So this is the answer. Okay. Next question. Left skewed distribution. Exactly opposite. Median is greater than mean. Okay. Now this is the question. A data set has a mean of 45, median of 55. The distribution is most likely. So you can see that here median is greater than mean, right? Median is greater than mean, median is greater than means this is a left skewed distribution. Okay. What is symmetric distribution? When they are equal. When will they be equal? When the data is distributed equally. Here the mean is equals to median. This is called symmetric distribution, uniform distribution. Okay. Next question. If the values in a data set are the same, then the standard deviation will be. If the values are same, let's say all values are 2, 2, 2, 2, 2. Then what will be the standard deviation? You know how to calculate standard deviation? Standard deviation means root over of variance. Now what is variance then? See, if your data set has 2, 4, 5, 9, 10. What is the mean value? We just calculated this data set mean value is 2. So we can write 2, 4, 5, 9, 10. Now mean value is 6. Then every data point is how far from the mean value. So you have to calculate x minus mu, that is 2 minus 6, 4, 4 and 6, 2, 1, 3. So minus 3 and minus 4. Okay. Now you have to calculate their square. So 4 square 16, 4, 1, 9, 16. Okay. Now you can calculate variation. So if you want to calculate the population variance, then you have to add them. 20, 21, 30, 46. So 46 divided by 1, 2, 3, 4, 5. 5. Okay, this is the population variance. And what is sample variance here? The samples variance is same. You have to add all the number, but divided by n minus 1. So 5 minus 1, that is 4. Okay, so whatever the answer is, that is sample variance. Now once you get population variance and sample variance, you can calculate population SD, that is population standard deviation, root over of this number, and sample standard deviation by root over of this number. Clear? So how you calculate variance? First you have to calculate the mean value, then you have to find the distance, because let's say your data set looks like this. This is the mean value. So you have to calculate how far is every data point from the mean, that is your variance, that is varying, right? If all the values are same, then what will be the standard deviation? All the values are lying here. There will be no difference. So that will be 0. If all the values are 0, so the final thing will result in 0 only. So this is 0. Okay. And if it is not the same number, then you have to calculate in this way. First you have to calculate the difference, then you have to do the square, then you can calculate population variance, sample variance, different formula, and from that you have to just calculate the root of them to calculate standard deviation. Clear? Now the next question. The shape of a distribution is given by. So the shape you can see, the shape you can calculate by skewness. So you can write by skewness. Okay. Now a distribution with long tails and many outliers. See, a distribution with long tails and many outliers. See, if you don't know, this is called kurtosis. That means it may look like this. Long tails and many outliers, said to have high kurtosis. Okay, so what is the difference between skewness and kurtosis? Skewness tells you about the distribution of both the tails, like how left tail is, how right tail is. Okay, if the left tail is longer, then left skewed. If the right tail is longer, then it is right skewed. But in case of kurtosis, it calculates the tailedness or the peakedness. Okay, and kurtosis is of many types. Let's say your distribution almost looks like normal. This is normal distribution, or you can say this is bell curve. Moderate peak, moderate tails. This is known as mesokartic. This is better. Okay. And if you calculate kurtosis here, you can calculate kurtosis also. So if you calculate, it will be almost 3. Okay, near 3. Now, if kurtosis is greater than 3, then it will be sharp peak and flat tails. This is greater than 3. Then it is known as lipokartic. Okay, and one more is, that is thin tails and flat peak. Here the kurtosis will be greater than 3. This is known as platykartic. Okay, mostly like uniform distribution. The data is uniformly scattered. Okay. So by this you can understand how your data is distributed, right? If the kurtosis is high, then it will be more peaked. If the kurtosis is low, sorry, this is less than. If the kurtosis is low, then it will be flat peaked. Okay. This is called kurtosis. Okay, so what is the difference between kurtosis and skewness? Skewness compares both sides. If it is like this, then left tail is longer, so left skewed. The opposite one, right tail is longer, right skewed. But here you are comparing tail with pickedness. Okay, so kurtosis is about tailedness with pickedness. Clear? How heavy or light the tails of a distribution are compared to a normal distribution. Normal, that means kurtosis will be 3. Greater than 3, that means levokurtic. Less than 3, that means bradykurtic. Clear? Now this one, we have already done this one. 2, 4, 5, 9, 10. Calculate population variance, calculate standard deviation. See this one. Hello everyone, welcome back to this channel. Today we are going to do some questions from probability. Before that, let me just give you a small recap. What is probability? Probability is a measure of how likely an event is to occur. Okay, let's say you throw a coin. Now a coin has two sides, head and tail. Now what is the probability that the outcome will be head or the outcome will be tail? Okay, so to calculate this, we write probability of any event equals to, let's say I want the outcome to be head. So what is my favorable outcome? Head, that will occur one time. And what are the total chances? One is head, one is tail. So 2. So it will be 1 divided by 2, right? Number of favorable outcome, whether it is head or tail, divided by total outcomes, right? Okay, let's do another example. Let's say I roll a six-sided die. Six-sided die. Okay, so it may be 1, it may be 2, maybe 3, 4, 5, 6. Now my question is, what is the probability of getting 3? Okay, so 3 will occur only once. So number of favorable outcome is 1. Total 1, 2, 3, 4, 5, 6. So total will be 6. If I ask you what is the probability of getting either 4 or 5, right? So 1 is 4, 1 is 5. So total number of favorable outcome is 2. Total number of outcome is 6. So 2 divided by 6 is the probability. Okay. So now the question is, what is the smallest possible value for a probability? So you can understand, if I ask you what is the probability of getting 7, then you will say it is 0 because there is no probability that there will be any 7. Right? In your die there is no 7. So the smallest possible value for a probability is 0. What is the largest possible value? Let's say I ask you what is the probability of getting from 1 to 6. Then all are the favorable outcome, right? 6 is the favorable outcome. It may be 1, it may be 2, it may be 3, 4, 5, 6. You are satisfying the conditions. Okay, your question is getting any number from 1 to 6. Okay, so all the favorable outcome is 6. Total number of outcome is 6. So 6 by 6 equals to 1. So the largest possible value is for a probability is 1. Okay, so to calculate smallest, you will consider any value that is not here. So that is 0. Or for largest, let's say you consider all the values that are present in your favorable outcome, then it will be 1. Okay, so always your probability will be between 0 to 1. The smallest is 0, the largest is 1, and all other you can see that there are something 0 point something, right? 0 0.5, 0 0.3 something like that. Okay. Next question. Match each pair of events to the correct type of event. What is mutually exclusive? Independent, dependent, complementary. Okay. First question is rolling a 3 on a die, rolling a 5 on a die. Tell me which types of event it is. So two types of events are happening. Event A, one dice is rolled. Event B, another dice is rolled. So what is the probability of getting 3 on a die? The probability is 3 by 6. Just now you have calculated. What is the probability of getting 5 on a die? The probability is 5 by 6. So you think that this one is related to this one anyway? No, they are completely exclusive. So they are mutually exclusive. They don't have any relation with each other. So this is the type of this event. Now let's do the next one. Flipping heads on a coin and rolling an even number on a die. See, it is a coin, it is a die. Do you think is there any relationship? No, they are completely independent. Right? In this case, both of them were die, but one is not related to another. But here, one is coin, another one is die, and they have no relationship at all. So you can say this is independent. Next one. Drawing an ace from a deck of cards, drawing a king from the deck after removing the ace. See, these are related. First you are drawing this one, and after you have drawn, then you have removed this. Then you are drawing again a card which you want to be a king. So you can see easily that one is dependent on this one. So this is dependent. Okay. Now the next one. Flipping heads on a coin, flipping tails on a coin. See, this is a coin and you are trying to flip this coin to become head. For event B, you want to become tail. So do you think that they are not related? No, obviously they are related. Are they independent? No. Are they dependent? No. They are complementary because either you will get or you will get tail. Okay. So either you get A or you get complement of A. This is called complementary. Fine. So 4 types mainly. Mutually exclusive, when both of them are different, like it can be 3, it can be 5, right? When they are completely different, independent. When one is dependent on another, dependent. And in this scenario, they are complementary because if this one happens, it cannot happen. Clear? So in this way, you can decide which types of event is happening. Now let's do the next question. Let's say probability based on personal judgment, intuition or experience. Not an exact calculation of data. You are not calculating this way, but you are doing any judgment, intuition or experience. So now tell me, which types of probability is this? Probability is of many types. Is it classical, empirical, subjective? This is called subjective probability. When you are not doing any calculations, then this is subjective because you are judging something. You are thinking that it may happen, right? Your intuition or your experience that is telling you that the probability of occurring any event is this much. This is called subjective probability. Okay. Next question. Based on actual observation, that means you have observed, you have calculated like 1 by 6, experimented or from historical data, then it is known as empirical probability. Okay. Next one is probability based on assumptions that all outcomes are equally likely. See, then it is known as classical probability. So 3 types of probability. Subjective probability based on your intuition. Empirical based on your calculation. And when all outcomes are equally likely, this is classical probability. Clear? Hello everyone, welcome back to this channel. So let's do some questions from probability. What is the sample space in probability? Sample space means total number of outcomes. Let's say if you throw a coin, your outcome will be either head or tail. So total 2. So 2 is the number of sample space here, right? Let's say you throw a 6-sided die. So either it will be 1 or 2 or 3 or 4 or 5 or 6. So total outcomes 6. So here sample space is 6. Okay. So total number of outcomes is known as sample space in probability. Second question. What is an event? An event is a set of outcomes. When you throw a die, then it may be either 2, it may be 4 or it may be 5, any number. So that outcomes are known as event. Okay. So what is the probability that the outcome will be 2 when you roll a die? That is known as event. Okay. Next question. What is the probability of a sure event? Sure means that will happen, right? If I throw any coin, so what is the probability that it will be either head or tail? 100% probability. There is nothing else other than head or tail, right? So that means the probability is 1. What is the probability of an impossible event? 0. If I roll a die and I expect the outcome to be 7, will that ever happen? No, because there is no 7 in the die, right? So that is an impossible event. So that is why the range of probability is between 0 and 1. Okay, it cannot be less than 0, it cannot be negative number, right? Or it cannot be more than 1. If it is sure, then it will be 1 only. Fine. Now the outcomes of a fair die roll. What is the outcome of a fair die roll? Is it a mutually exclusive? Yes, if you roll a die, let's say the outcome may be 3. Next time the outcome may be 5. Any event is dependent on other event? No, not at all. So it is mutually exclusive. Independent? Yes. It is not dependent on this one. So this is independent also. So the answer will be both A and B. Fine. What is independent event? When one event is depends on another. Right? Let's say you have removed a king from deck of cards. First you have got a king and you have removed that. Then again you are checking what is the probability of getting a king again. That is a dependent event because earlier there were 4 kings but now you have removed one. So there are only 3 kings. So that is why that is dependent event. Okay, in last class we discussed this in details. Now 2 events are called mutually exclusive if they can occur together, one must occur, they cannot occur together, and they are complementary. 2 events are mutually exclusive if they cannot occur together. Rolling a die and getting a 3 or getting a 5. Can it happen together? No. So that is why they cannot occur together. This is known as mutually exclusive. Okay. Events are independent if one does not affect the other. If affects, then it is dependent. Which term describes all possible outcomes of a random experiment? Event, trial, sample space. See, all possible outcomes. That was our first question. That is known as sample space. Okay. All the outcomes. Head, tail, total. Right. The complement of event. Complement always means that contradiction. Opposite of A. Or we can say 1 minus A. That is the answer is outcomes not in A. Okay. Like getting head or tail. Either it will be head or it will be tail. That is complement. Okay. Next, a random experiment is one whose outcome is uncertain. That is why that is random. We don't know what will be the outcome. So we are doing random experiment. What is the term for a single result from a probability experiment? Single result from the experiment. After you have done the experiment, there is a single result. That is known as outcome. Okay. And a set of outcomes is known as what? Event. Okay, total outcomes. The number of favorable outcomes divided by the total outcomes. That is what is probability. What is the definition of probability? Definition is number of favorable outcomes divided by total outcomes. What is the probability of getting 3 divided by total number of outcomes? That is 1, 2, 3, 4, 5, 6. So 3 will occur once. So 1 divided by total 6. This is what is known as probability. Okay. Okay, now let's do the next question. 2 events are complementary. Complementary means you know that both of them cannot occur together. So P of A equal to 1 minus P of B. See, this one is intersection, right? This one looks like this. And this total thing is union, right? This looks like this. So the formula is P of A union B. If I want to write this one, then I have to write PA plus PB minus PA intersection B. Because you have to take the complete A, you have to take the complete B. But you can see that this portion is added twice. So I have to remove this once. So that is why you are removing this. Okay. So PA plus PB minus the intersection point. Now see here. This is complementary. Complementary means this one can never happen together. There is no interconnection, right? They are completely separate. So in this case, there is no intersection point. So this portion will become 0. So it is PA plus PB. This is the complete sample space. So we can say A union B is the sample space. Okay, right? There is no intersection point. Fine. Next question. A trial in a probability is repeating the same experiment once. All possible outcome is sample space. A favorable result, the same as a sample space. What will be the answer here? Repeating the same experiment once. If the probability of an event A is 0.3, then what is the complement? I just said 1 minus 0.3, that is 0.7. Because right now you have just studied A union B equal to sample space. So here A union B equals to 0.7 plus 0.3, that is 1. Okay. The probability of the sample space. Sample space means total number of outcomes, right? So the probability of sample space is 1 because you are considering every value. So it is a sure event. At least one of them will be from 1 to 6. That is why the probability is 1. Fine. Second question. If A and B are mutually exclusive, that means TA doesn't depend on the other, right? So the answer will be P of A union B equals to PA plus PB minus PA intersection B. This is the formula you know. Mutually exclusive event means this is simply 0. So the answer will be PA plus PB. Okay. The second one. Now if an event is impossible, probability is 0. Which of the following is not true about probability? Not true. It is always non-negative. That is true. As I said, it will always be from 0 to 1. It can never be negative number. Right? The sum of all possibilities in a sample space is 1. Exactly. Probability can be greater than 1. No, that is not true. The probability of an impossible event is 0. That is also true. So, the answer is C. Okay. Next question. If A and B are two disjoint events, then what is P A intersection B? Disjoint event means there is no relation. So, A is separate, B is separate, like complement. So, the answer will be 0. No intersection. So, 0. Next question. If PA equal to 0.6, PB is equal to 0.3 and they are mutually exclusive. See, right now you have just seen mutually exclusive means PA union B equal to PA plus PB, right? So, always use this formula, then you will be able to solve this. PA plus PB minus PA intersection B. See, this portion will be 0 when it is mutually exclusive. So, here you have 0.6. PB equal to 0.3, so it will be 0.9. Fine, the answer will be 0.9. Okay, so let's meet in our next class. Bye, happy learning. Hello everyone, welcome back to this channel. So let's do some questions from probability distributions. Okay, first question. You are analyzing human heights in a population which tend to cluster around mean with a symmetric spread. Which distribution best fits the data? See, let's say you are calculating human heights. Okay. Now, it tends to cluster around mean. See, this is the mean. So, maximum values are lying here only. And with the symmetric spread, it is not skewed, right? So, it will look like this. You can easily say this is a normal distribution, right? Because normal distribution naturally cluster around mean. Most of the values are lying here and very few values lying in this side, and it is symmetric, so it is not skewed. So this is a normal distribution, right? It looks like bell shaped curve. Once you know that your data is normally distributions, you have pretty much idea about your data set, right? That's why we need to learn the distributions, right? Second question. If you are modeling income distribution where a small percentage of people earn the majority of wealth, so there is a disparity. So from this word you can guess which is the answer. See how it looks. Small percentage of people, let's say people. This side probability of wealth. Small percentage of people gets maximum probability of getting wealth. See, less percentage of people have less wealth, right? So, you can see it will look like this. This will be reduced. As the number of people increases, their wealth decreases. And for less people, the wealth is like the highest. So, there is a disparity. It is known as Pareto distribution. This is very famous. Okay. Minimum people are holding the maximum of the wealth. The third question. A machine generates random number between 0 and 1. It may be 0.05, 0.06, any number, and each number equally likely. No disparity. Any number can happen. So the outcome is uniform. Anything can happen. Okay, so the distribution is uniform distribution. And it is of mainly two types. One is for discrete, another one is for continuous, right? And for discrete, you calculate probability. For continuous, you calculate probability density. I hope you know this thing. If you don't know, you have to study. This is uniform distribution. If I roll the die, it may be 1, 2, 3, 4, 5, 6. So happening of anything is equal to 1 by 6. Right? This is discrete uniform distribution. Each number is equally likely. Next one, the data on stock prices. Fine. When you take the logarithm of the values, it appears normally distribution. This is simply log normal. See, when our data is skewed like this, or let's say like this, left skewed or right skewed, then what do? We try to make them look like normal. Then only our algorithm will work the best. So this is done by using logarithm of every values. Okay, this is one procedure. There are many procedures, but one of them is to take the logarithm of this one, right? So that is what they have asked. When you take the logarithm of the values, they appear normally distributed. When you take log, they appear like normal. Before that, they may have any types of skewed form data. Okay, so this distribution is called log normal distribution because it will not exactly become normal, but almost normal, better than your skewed, right? That is why log normal. Next one, which distribution is appropriate to model the number of accidents occurring at a traffic intersection a day? See, per unit time. When you do these types of calculation, that may be from 7 to 8, how many accidents have happened. From 9 to 11, or maybe on Sunday, how many accidents. Or maybe on Monday, how many accidents. When you are just considering the periods, the time period, then you have to go for Poisson distribution. Okay. Next one, you are modeling the lifetime of an electronic device, assuming the probability of failure is constant over time. The probability of failure is constant. So, this is something fixed, you cannot change, and you are modeling the lifetime of an electronic device. See, this one is best fitted for exponential distribution. Because when the probability of failure is constant over time, you have to consider the exponential distribution. Okay. Now the next question. If you roll a fair die, each outcome has an equal chance. This one we have already done. If each outcome has an equal chance, then this is discrete. Why discrete? Because here 1, 2, 3, 4, 5, 6, they are separate number. But when you have to consider some numbers like 0.005, 0.0008, then that will be continuous uniform distribution. Okay. Now the last question for that day. A bus arrives at a stop at any time between 8 am and 8:30 am. And if you arrive at the stop at a random time between that interval, this one also we have just discussed. If you are calculating anything based on time, based on some fixed frequency, then the best suited one is Poisson distribution. Okay. Hello everyone, welcome back to this channel. So today we are going to discuss some questions from the distributions of probability. Okay, first question. Which of the following base defines a Bernoulli distribution? What is a Bernoulli distribution? If you throw a coin, you will either get head or you will get tail, right? So we can say either success or failure. And when the trial is done only one time, so it is one time and two outcomes. That means this is a Bernoulli distribution. Okay, now let's read this. A distribution that models time between events. Time between events means exponential distribution. We discussed in our last class that it will work until failure. A distribution of multiple trials with two outcomes. Two outcomes is fine, but not multiple trial. When it becomes multiple trial, then it will become binomial distribution. Okay, so this is also not correct. A distribution of a single trial with two outcomes. That's what we have discussed. Single trial, 2 outcomes. A distribution with many possible outcomes per trial. This means multimonial distribution. That means here trial is also multiple times and the outcomes are also multiple types. Okay. Let's discuss all of them by an example. So let's summarize the thing. Bernoulli, binomial and right. So Bernoulli means one trial and 2 outcomes, either head or tail. Fine. But when multiple trials and 2 outcomes, that means you are throwing a coin multiple times, but outcome will always be 2, either head or tail. Multimonial is multiple trials and multiple outcome. Example is, let's say you throw a die. So your outcome is from 1 to 6 and you throw it multiple times. So let's say you throw a die for 12 times. Right. So first time it may be from 1, 2, 3, 4, 5, 6. Second time it may be from 1, 2, 3, 4, 5, 6. This way it will continue 12 times. So you are doing multiple trials and multiple outcomes. Okay. So you understand the difference between these three. Second question. Which of the following defines a binomial distribution? Just we have understood that binomial distribution means distribution of the number of success in a fixed number of independent Bernoulli trials. When it becomes multiple, it becomes binomial. Okay, outcome is only 2. Continuous distribution of values between 0 and 1. What does it mean? Which kind of distribution? This is continuous uniform distribution. Right, because it is always between 0 and 1, uniformly distributed. Why continuous? Because it may be 0.2, 0.3 like this. Okay, if it was 1, 2, 3, then we can say discrete continuous. Clear? Third one, time between random events, exponential distribution, total number of events in a fixed interval, that is always Poisson distribution. Right? Fine. Next question. A coin is flipped once. What is the probability distribution of this event? Flipped once. So it may be head or it may be tail. So one trial, 2 outcomes. Tell me the definition. One trial, 2 outcomes means it will be Bernoulli distribution. Fine. A coin is flipped 10 times. Okay, so multiple trial. Fine. Which distribution would model the probability of getting exactly 4 heads? And in each trial you will get either head or tail. So the concept is same, that is binomial. Now you roll a fair 6-sided die 12 times. That's what we have just discussed. What is the probability model that describes the number of times each face appears? Multiple trials and multiple outcomes. So it will go for multinomial distribution. Which of the following distribution is continuous? Binomial? No, binomial, what are the outcomes? 0, 1. This is not continuous, discrete, right? So Poisson distribution, normal, Bernoulli. Normal is the continuous distribution. Okay, this is also 0 or 1. Poisson is fixed within a time interval. Okay. Now next question. You are modeling the number of calls arriving at call center per minute. When the time concept is there, then you can easily say this is Poisson. Because in a fixed time interval, you are trying to predict the calls arriving at the call center, right? The lifetime of a light bulb, exponential. A machine produces parts with lengths evenly spread between 4 and 6 mm. This you can easily say this is uniform. Because it is evenly spread, right? 6 centimeter. What is the variance of Bernoulli distribution with P? See, let's discuss mean and variance. I will just tell you the formula. Mean equals to, for Bernoulli means single trial, multiple outcomes. So let's say first outcome is head and head is your success. So your mean value will be P into 1 plus not getting success, so 1 minus P into 0. Not getting success means 0. So 1 minus P probability into 0 equal to 0. So it will be ultimately P. So the mean value is P, or we can say this is the expectations of X. This is P. Okay. So if anybody asks you what is the mean value of Bernoulli, you can say P. But what is the mean value of binomial? See, this is the same thing but happening multiple times. So if it is happening n times, then mean will be n into P. Fine. Now what is variance? Variance is P into 1 minus P for Bernoulli. And same things for binomial, it will be n into P 1 minus P. Okay, this is the formula you can apply and you can solve this. What is the variance of Bernoulli distribution with P equal to 0.3? See, variance for Bernoulli, that is P into 1 minus P. The probability of getting and probability of not getting. That is the variance. So 0.3 into 1 minus 0.3, which is 0.7. So 0.3 into 0.7 equals to 0.21. Fine. Okay, now the next question. A binomial experiment has n equal to 5, p equal to 0.2. What is the expected value? Expected value means we can say this one, mean. So for mean for binomial is n into p. So we can write n into p. Here 5 into 0.2, 0.1. Okay. For Bernoulli, this will be only 0.2. For binomial, this will be n into p. Clear? So for Bernoulli, the expected value is p. For binomial, n into p. Variance p into 1 minus p. For binomial, n into p into 1 minus p. Okay, so we have discussed all the questions. Now if you want to read the theory part, then you can simply go here and click on these topics and statistics. Here I have discussed these things in details, so you can study from here. The link of this blog I will post in the description box. Okay, so meet in our next video. Till then, bye, happy learning. Hello everyone, welcome back to this channel. So today we are going to do some numerical questions from probability. Okay, now first question is, what is the probability of getting a head when a fair coin is tossed once? See, before that, let me tell you the definition of probability. The definition of probability is number of favorable outcome divided by total outcome. Probability means chances of occurring any event. You are throwing a coin and you want it to become head. So what are the chances that you will get it as a head? Okay, not as a tail. That is what is probability. What is the probability of occurring a head? Okay. So now, see, first question, getting a head when a fair coin is tossed. So when a fair coin is tossed, it will either be head or tail. So total number of outcomes is 2. But what is my favorable outcome? That is getting a head, and head will appear one time. So the favorable outcome is 1 divided by total outcome is 2. So the probability will be 1 by 2 or 0.5. Clear? Now the second question. A die is rolled once. What is the probability of getting a number less than 4? Die is rolled once. That means it can be 1, 2, 3, 4, 5, 6. Any number, right? So total number of outcome 6. So it will be 6. But you want a number less than 4. So your favorable outcome 3 or 2 or 1. So total 3. Okay. So any one from this is your favorable outcome and that will be on the top. Okay. So total number of favorable outcome divided by total outcomes. That is 3 by 6. Clear? This is how you calculate probability or chances of occurring any event. Now, two events are independent. Independent event, that means A intersection B equal to PA into PB. Okay, they are not dependent on each other, they are completely independent. So, they are occurring together is this, PA into PB, this portion. This is A, this is B. Okay, so here PA equal to 0.5 and 0.4. So it will be 0.20. Okay. Now, if the probability of an event is 0.65, so probability of A equal to 0.65. What is the probability of its complement? Complement means P of A bar, that is 1 minus P of A. So 1 minus 0.65 equal to whatever 0.35. Exactly opposite is the complement, right? Head is the complement of tail, right? Now next question. A bag contains 3 red, 5 black. See, red, black. 3 red balls, 5 black balls. And 1 ball is drawn at random. What is the probability? It is black. See, what is the total outcome? 8. because 3 red balls, 5 black balls, so total outcome is 8. What is your favorable outcome? That is black. So any one from here. So total 5 blacks are there. So it will be 5 by 8. Clear? Now which of the following is a valid probability value? See, minus 0.1, no, it cannot be, because we know the value of probability will always be between 0 to 1. 1.2, not greater than 1. 0.8, yes. 1.5, not greater than 1. Clear? So 0.8 can be a valid probability value. Next one. A coin is tossed 3 times. What is the probability of getting 2 heads? See, one coin tossed 3 times. So, first attempt it may be all of them are head, right? Second attempt it may be head, but this may be tail. All of them are thrown at the same time. Next, maybe this is head, but this is tail, this is also tail, right? Next time maybe this is tail, but these are head. Maybe this is tail, this is also tail, this is head. Or maybe this is tail, but this is head and this is tail. Same way, again, it may be head, it may be tail, it may be head, right? Or maybe all of them are tail. These are the total combinations, right? So 1, 2, 3, 4, 5, 6, 7, 8. So this is total 8. Or simply we can calculate that 3 times and outcome is 2. That means 2 to the power q. That is 8. For every scenario, either head or tail, right? And it is done 3 times. So that's why 2 to the power q. This is 8. So this is total number of outcomes. That will be here. Fine. Now my favorable outcome is what is the probability of getting exactly 2 heads. See, here it is exactly 2 heads? No. Here, yes. Here exactly 2 heads? No. Yes. No. No. Yes. No. See, 1, 2 and 3. Okay. So the favorable outcome is 3. So this will be answer 3 by 8. Clear? Whatever the question is, what is the probability of getting exactly 3 heads? 1 by 8. What is the probability of getting no head? This one, 1 by 8. So this way, whatever the question is, you can simply calculate. Okay. Next, if two events are mutually exclusive, then P A intersection B. See, they have already said that they are mutually exclusive. And what is A intersection B? A intersection B means the common part. This is A, this is B, this is A intersection B. But if they are mutually exclusive, that means A, B are completely separate. They can never touch each other, right? They are mutually exclusive. So this portion will not exist at all. So this is simply 0. Okay. Next one. If PA equal to 0.7, PB equal to 0.5, PA union B equal to 0.9, then what is PA intersection B? This is a very famous formula, you know. PA union B equal to PA plus PB minus PA intersection B. Right, I told you, A union B. That means the complete thing, right? That's what you want to calculate. So you have to take the whole of A, that is PA. You have to take the whole of B, that is PB. And you can see that this amount is calculated twice while taking A and while taking B. So you have to remove this once. So minus PA intersection B. And this portion you know it is intersection. That's what I have written here. Now here you just put the value 0.7 plus 0.5 minus this is 0.9 and this is PA intersection B. So you just do the calculation. Okay. Next question. In tossing 2 coins, the probability of getting at least 1 head. Okay. See, you are tossing 2 coins. So first one may be head. Second one also may be head. First one head. Second one tail. First one tail. Second one head. Now first one tail. Second one is also tail. Total. I have also told you are tossing 2 coins and each of them can either be head or tail. So outcome is also 2 times and you are tossing 2 times. So 2 to the power 4 will be total outcome. That is what is here. So 4. Now my favorable outcome. At least 1 head. At least 1 head? Yes. At least 1 head? Yes. At least 1 head? Yes. no head. So this is 3 out of 4. This will be the answer. Okay. This is also considered because it is told at least. Okay. Not exactly. Next one. A number is chosen at random from 1 to 10. What is the probability it is a prime number? See, a number chosen from 1 to 10. So total outcomes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can choose any number from here, right? So total outcome is 10. What is the favorable outcome? That is prime number. 1, 1, 2 is a prime number, 3 is a prime number, 4 no, 5 is a prime number, 6 no, 7 is a prime number, 8 no, 9 no, 9 can be divisible, 10 no. So 1, 2, 3, 4. So total 4 out of 10. 2 by 5. Okay. Now, if an event has the probability of event, what can be said about the event? Probability of 1, that means that will happen. Okay, whatever you do, that is a sure event. So, I can write certain event. Okay. Now, if a card is drawn from a deck, what is the probability that it is not a spade? Okay, for that you have to know about the cards, that how many are spade and other types of card. So total we have 52 cards, and among them 13 cards are spade cards. Okay, so you said that it is not a spade. So what is your favorable outcome? Other 39 cards. If I minus, then it will be 39 cards exactly. So your favorable outcome is not a spade. So any number from other 39 cards. And total you have 52 cards in a deck. So that is the answer. So now you can simply divide. It will be 3 by 4 divided by 13. Okay. Now, if events A and B are independent, then what is the value of P A union B? See, now you can do it. P A union B equal to P A plus P B minus P A intersection B, right? P A you know 0.6 plus 0.5 minus P A intersection B. You have said this is independent. When you say it is independent, that means P A into P B is the solution. So now here put 0.6 into 0.5. Okay, so you add them 0.11 minus 0.3, so it will be approx 0.8. Okay, that is fine. Now, what is the probability of getting a sum of 7 when 2 dice are thrown? See, first dice, let's say this is 1. Second dice, also 1. First 1, second dice 2. 1, 3, 1, 4, 1, 5, 1, 6. Right? First time. Now second dice 2, first dice 1. 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. Or it may be 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. I am taking the first as constant and I am taking all the values from the second one. Same way 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. Same way 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6. And last 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. So 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So total 6 into 6 equal to 36. You can count 6, 12, 18, 24, 30, 36, right? Or you can simply calculate from here that you are throwing 2 dice, right? So first probable outcome is 6 different types, or you can say you are throwing 2 dice. You don't need to write these things, okay? For the first time I am just telling you that so that you can understand what are the probabilities. But 2 dice, so first one can be any value from 1 to 6, second one can be any value from 1 to 6. They are independent, so total 6 into 6, 36 types of events can happen, okay? So this is total number of outcomes. Now, what is the probability of getting a sum of 7? Now tell me. Sum of 7? No. 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 Yes. Sum of 7? No. No. 6, 7. Yes. No. 5, 6, 7. Yes. No. 7. No. 6, 7. Yes. No. 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 6, 7. Yes. No. 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 So everywhere you can get one value. So total you can get 6 value. So 6. Okay. Or once you know these things, you can simply calculate by yourself that at least 1 with 6, then only it will become 7. If the first one is 2, then 5 you need to become 7. If first one is 3, then you need 4 to become 7. If the first one is 4, then you need 3 from 7. If the first one is 5, you need 2 to make 7. First one is 6, then you need 1 to make 7. Right? So 1, 2, 3, 4, 5, 6. So total 6 favorable outcome can happen to get exactly a sum of 7. Simple. So the answer will be 1 by 6. Okay. If the question is something like getting a sum of 8, let's say, then getting a sum of 8 means you think that first one is 1. So if the first one is 1, then the second one have to be 7 to make it a 8, right? But that is not possible. 7 is not available. So this can be a solution. If the first one is 2, then the second one has to be 6. That is possible. If the first one is 3, then the second one has to be 5. That is also possible. If the first one is 4, then second one also has to be 4. That is also fine. First one is 5, then second one 3, 8. That is also possible. If the first one is 6, second one has to be 2, 8. That is also possible. And now first one cannot be 7. So I have total 1, 2, 3, 4, 5. So it will be 5 by 36. Same way you calculate what is the probability of getting a sum of 9, getting a sum of 10, okay, anything. Now, a number is selected at random from 1 to 100. What is the probability that it is divisible by 5? First of all, any number from 1 to 100, so total outcome 100. No doubt with that. But favorable outcome is divisible by 5. So what are divisible 5? 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, right? 55, 60, 65, 70, 75, 90, 95 and 100. Right? You have to just multiply. 5 into 1, 5 into 2, 5 into 3, 5 into 4, 5 into 5. This way. Now you just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So it will be 20 by 100. That is 1 by 5. Okay. Okay, now the last question. Which rule allows you to compute PA intersection B when A and B are dependent? Okay, so first is Bayes rule. Let's understand what is Bayes rule. Bayes rule simply means what is the probability of occurring event A when event B has already happened. Okay, this is the past. This has already happened. So what is the probability of occurring event A? Okay, it's like what is the probability of happening, what is the probability of raining today when yesterday it has already rained, like this. So this is probability of event B given that A has already happened, exactly the opposite one, into probability of event A divided by probability of event B. Okay, so as per Bayes, this is the formula using which you can calculate what is the probability of occurring event A when event B has already happened. This is known as Bayes rule. Second one is addition rule. Addition rule we already know, PA union B equals to PA plus PB minus PA intersection B. We have already done some maths using this rule. Third one is conditional probability. Conditional probability means PA given B equals to PA intersection of B divided by PB. That is also a probability of occurring event A given event B. Okay, to calculate this, you can use this formula. This is known as conditional probability. So Bayes' theorem is based on this conditional probability. Right? Now the last one. Multiplication rule for independent events. That means P A intersection of B equal to P of A into P of B. They are independent. So what is the solution? This is independent event, so this is not a question. Addition rule, that is also not. So to compute A intersection B, see this one. P A intersection B equals to P of multiplication of them. A given B into P of B. Right? So the answer is conditional probability. Okay. So done for the day. Bye. Happy learning. Hello everyone, welcome back to this channel. Today we are going to discuss some MCQs from central limit theorem. Okay, before that, just let me tell you the definition once. What is central limit theorem? Central limit theorem states that the distribution of the sample means will approximate a normal distribution regardless of the shape of the population distribution as the sample size becomes large enough. That means whatever your population distribution is, let's say this is population and you don't know what is the distribution of this population. That means you don't know whether it is continuous, normal, discrete continuous, uniform continuous, Poisson, you don't know simply. But this theorem states that once you take a sample of large size, it will behave like a normal distribution. Clear? And the large size generally means the sample size greater than or equal to 30. Okay, let me tell you once again. Whatever the population distribution is, once you take a sample of large size, then it will behave like a normal distribution. Okay, now let's solve the question. What does the central limit theorem state about the distribution of sample means? About sample means. Sample means are always normally distributed. No, if the size is not large enough, then it may not be normal, right? It may follow its population distribution. Once it becomes large size, then only it behaves like a normal distribution. So this is not right. Sample means approach a normal distribution as the sample size increases, regardless of population distribution. That is the definition. Okay. Sample means follow the same distribution as the population for smaller size, not for larger size. Sample means are only normal if the population is normal. No, that is not true. But if it is normal, it will also become normal. But the only word is wrong here. Okay. Second question. What is the minimum sample size for the theorem to apply? I have already said greater than equal to 30. Okay. Large sample size generally considered like this. If the sample size is greater than or equal to 30, that means it is a larger size and it will follow the normal distribution. Third one. According to the theorem, what happens to the standard error as sample size increases? Error will become lesser, so it will decrease. Okay. Now, if a population has mean equal to 50, standard deviation equal to 12, what is the standard error? See, the formula for standard error is sigma by root over of n. Standard deviation here is 12 divided by n is the sample size, so root over of 36. So 12 divided by 6 equals to 2. Okay. Next question. The central limit theorem applies to only normally distributed. No, population distribution is unknown. Only population with finite variations. Most populations with finite mean and variance, exactly. The population should have finite mean and variance. Large population, no, not required. The shape of sampling distribution of sample means depends on what? Only on the population distribution. Only the sample size. Both the population distribution and the sample size, exactly, both. Sample size also matters and population distribution also considered. Okay. If the population distribution is, let's say, uniform continuous and you take a small size, then what will be the population distribution of sample? Uniform continuous. So the sample size will follow its population distribution if the sample size is smaller. That's why it is dependent on both. For a highly skewed, generally it is considered that if this is highly skewed, like this much skewed, for that you will take n greater than equal to 50. N is the sample size. Okay, now the next one. The central limit theorem is important because it makes all the distributions normal. For that you have to take greater sample size. Allow statistical inference even when population distribution is unknown. That is true. That is the main thing, that we don't know the population distribution, but I know that my sampling distribution is normally distributed if I have larger sample size. Eliminates sampling error? No, that is not possible. Reduces population variance? No, that is also not topic. Okay, so we have discussed all the questions from central limit theorem. I hope the concept is completely clear to you. Okay, so meet in our next class. Till then, bye. Happy learning. Hello everyone, welcome back to this channel. Today we are going to understand what is the difference between inferential statistics and descriptive statistics. Okay, we will solve the MCQ, but before that, let's read out the definition once. Descriptive statistics means that deals with summarizing and organizing data so it can be easily understood. That means you have a complete data set and you want to understand what is the mean value of the data set, what is the median value, mode value, standard deviation, variance, and you can plot some kind of charts, graphs. All these things comes under descriptive statistics. Okay, these things we have learned. Purpose is what the data shows. But maybe your population is 10,000 and it may not be possible for you to get the data for all of them. So what you do, you take a sample from here, let's say of 100 people, and then you calculate different kinds of statistics to predict about the population. That is what comes under inferential statistics. See, it involves using a sample of data to make predictions or generalizations about a larger population. So from the sample, you are predicting the population. Okay. So in descriptive statistics, there is no concept called sample. You are considering the whole population. But in inferential statistics, you are taking the sample to do prediction. Okay. Now, examples: hypothesis testing, confidence interval, regression analysis, p-values, to draw conclusions and make decisions beyond the data you have. Okay. You don't have the complete data, but you have the sample and you are doing the predictions of the population. Now let's do the questions. What is the main purpose of descriptive statistics? To make predictions about population. That comes under inferential statistics. Test hypothesis, inferential statistics. To summarize and describe features of dataset. Yes, that's what descriptive statistics do. To infer values from a sample. No, that is also inferential statistics. Second question. Which of the following is not a part of descriptive statistics? Mean is a part, so it cannot be an answer. Histogram, this is a chart by which we represent data. Confidence interval, this is part of inferential statistics. Okay. We will do more MCQ from confidence interval. Median is also is a part of descriptive statistics. So the answer is confidence interval. Now descriptive statistics are typically used to generalize result from a sample to a population. Inferential statistics analyze the correlation between variables, organize, summarize and present data, perform hypothesis test. This is also inferential statistics. So we have organize, summarize and present data. Okay. What is the primary purpose of inferential statistics? Primary purpose is you have to draw the conclusion about a population based on a sample data. This is the exact definition. All the values in data set? No, that is descriptive. To display data using graphs? Descriptive. To calculate descriptive measures like median, mode? That is also descriptive statistics. Which of the following is an example of inferential statistics? Calculate the mean height of students in a class. Creating a pie chart, descriptive statistics. Estimating the average salary of all engineers based on a sample. Finding the mode of a dataset, descriptive statistics. Okay, see, this is mean. So descriptive statistics, pie chart, descriptive statistics, mode, descriptive statistics. But you are estimating average salary based on a sample. So simply inferential statistics. The last one, hypothesis testing is a part of descriptive statistics. No. Inferential statistics, yes. From hypothesis testing also we will do many MCQs. Okay. Data collection. Data collection is neither descriptive nor hypothesis. You are collecting the data. Data visualization comes under descriptive statistics. Okay, so I hope this is completely clear. In descriptive statistics, you consider the complete data set, you calculate mean, median, mode, different kinds of charts and graphs. But in inferential statistics, you take a sample from the population and then you are trying to predict the population. Okay, and different things like chi-square, ANOVA test, F-test, p-value, all these things comes under inferential statistics. We will do MCQs and understand these concepts also. Okay, so meet in your next class. Bye, happy learning. Hi everyone, welcome back. Today we are going to discuss 10 MCQ questions from the very basics of inferential statistics. Okay, before that just let me give you a small recap. Let's say you want to calculate average height of people of any particular village, and in that village there are 10,000 people. So you just want to know their mean height. Okay, but you cannot go to everyone's house and calculate their height. So what you do, you take some people from here, let's say 200 people, and you calculate their mean height or average height, and then you try to guess what will be the height of the complete population. Okay, so this complete thing is known as population, the entire group. Okay, the entire group what you want to study, and this is sample. That means some people you have taken for measuring. Okay, so this is known as sample, and for sample this is called statistic, whatever it is, mean, median, mode, anything else. And for population this is called parameter. The same thing, but for population it is known as parameter, for sample it is known as statistic. Okay, this is the basic thing we know. And one more thing that we know, what is inferential statistic and what is descriptive statistic. Inferential statistic means when you take the sample and you try to guess the parameter of any population from the statistic of the sample, then it is called inferential statistic. And when you study the complete population, you try to represent it through any graph or anything else, then that is called descriptive statistics. Okay, these things we already know. Now let's do the questions. In inferential statistics, what is a sample? Sample is a subset of the population. Yes, the entire group we want to study, that is population. Always equal to the population? No, it is not equal. A type of variable? No, it is not a type of variable. Okay. Second question, a parameter. Parameter I told you that is related to population. So a number calculated from sample data. Calculated from sample data means statistic, not parameter. So a number that describes the population. Exactly, it describes the population. Always equal to statistic? No, it may be more or it may be less. Okay, from statistic we guess what will be the population parameter, that may be equal or may not be equal. Okay, anything. Now, not used in inferential statistics, that is wrong. This is all inferential statistic. Which of the following terms refer to a value calculated from a sample? Statistic. Okay, which of the following is an example of statistic? The average age of all citizens in a country. All citizens, that means population. Population means it is a parameter, right? So it is not a statistic. The average income of 100 surveyed people. See, here we have taken a sample and we have calculated. So this is the right answer. The known population mean height, not known. The census data from government, no, that's a data. Which statement is true? Inferential statistics summarize sample data only. No, from the sample we are trying to calculate the parameter, right? Descriptive statistics draw conclusion about population. No, I just told descriptive means it is just representing that complete data. Inferential statistics involve generalizing from samples to population. Exactly. From inferential statistics only we can generalize from sample to population. Okay. Which of the following is an example of inferential statistic? Drawing a pie chart, descriptive. Calculating the mean age of a sample, that is an example. But estimating the average height of all adults based on a sample, this is the complete inferential statistics. Here you are calculating sample, this is fine. But when you get something like from the sample you are trying to estimate the parameter, that is the best example of inferential statistic. Okay, so this is the right answer. Now, what is the purpose of confidence interval? From confidence interval we will do many MCQ, but for now just understand that confidence interval is a range of values that is used to estimate an unknown population parameter. It tells like 95% confident that the true value lies in a particular range, maybe from 10 to 20. Okay, like this. Or let's say average height is between 4 to 6. A range of values. Within this, your mean height will lie. Okay, so you can say that you are 95% confident to say this. Fine, this is called confidence interval. So to find exact, no, not exact, I told you this is a range. To show the full population data, that is not true. To estimate a range where the population parameter likely lies. Exactly. From sample, we are trying to guess what will be the range where the population parameter will lie. Okay, this is the answer. Now next question. What is sampling error? Sampling error means a mistake in collecting data? No. The bias of the researcher? No. The difference between a sample statistic and a true population parameter. See, from the sample you are trying to guess the population parameter. So it will not be exactly correct. There will be mistake always. So that is the difference is called sampling error because that is happened due to sampling. Okay. Why do we use samples instead of studying the entire population? Why? Because it's more accurate? No. Population don't exist? No. It's easier and often more practical. It is not possible for you to go everybody's door and ask for their height. Okay. So more practical approach is you take a sample. What is a population? Population is always smaller, no question. A group of people? No. The entire group about which we want to make the conclusion. Okay. The complete group. The main tool used in inferential statistics is data collection? No. Graphical analysis? No. Hypothesis testing? Yes. Data entry? No. Okay. About hypothesis testing also we will do many questions in our later classes. So I hope you understand these are the very basic questions and easy session to understand what are the things in inferential statistics. Okay. So bye. Happy learning. Hi everyone, welcome back. Today we are going to discuss questions from confidence interval. But before that, let me give you a small recap. First, understand what is confidence interval. See, if you want to find the average height of students in your university, you cannot measure everyone. So what you do, you take a sample of 50 students. Then you calculate the average. But it may be quite different from the true average, right? So instead of taking a simple single digit, you are taking a range of values. That is what is confidence interval. So confidence interval gives you a range of values that likely includes the true population parameter. Okay, so instead of saying that the average height is 165, you are saying that we are 95% confident that the true average height lies between 160 to 168. It may be 163, 167. Okay, so you get my point. Instead of giving a single digit number, you are giving a range of values and you are saying that you are 95% confident. Clear? Now, this is the formula. X is the sample mean, Z is the Z score. It depends on the confidence level. For 95% it may be different, for 96% it is different. From the table you will get this Z score. Okay. Sigma is population standard deviation and root over n is the sample size. Okay, 50 like here. So by using this formula you calculate the confidence interval. Okay, so 95% confidence interval means if we repeat the sampling process 100 times, 95 of this confidence interval would contain the true population mean. Clear? It doesn't mean that there is a 95% chance that the true mean is in your calculated interval. That's what a mistake people does. You have to keep it in mind. This is not about how much percentage chance. But it means that if you sample 100 times, 95 of this resulting confidence interval would contain the true population mean. Okay. So 95% is the method, not the specific result. Fine. Okay, so this is it. Now we are going to do the MCQs. See, first question. What is the purpose of confidence interval? To summarize raw data? No. To calculate population mean? No. To estimate a range in which population parameter lies? Exactly. It is a range like 162 to 168, and I want to say that the mean height lies here. What happens to the width of confidence interval when the sample size increases? See, if the sample size increases, then width of confidence interval will become low. Sample size increases means you are getting more points. That means you can calculate more perfectly. So your range will get reduced. Now you can see 160 to 165. Correct. What does 95% confidence interval means? This is a very important question. See, there is a 95% chance. No. Whenever you get like this 95% chance, no, that is not correct. That is not a result. Okay, that is a method. Keep it in mind. The population has a 95% chance of lying in interval. No. If we take many samples, about 95% of the intervals would contain the population mean. Exactly. If we take 100 samples, then 95% of this interval will contain the population mean. See, this many interval you have, and 95% of this confidence interval will represent the true mean. Okay. Okay, next question. Which of the following will result in wider confidence level? Wider, let's say 160 to 170. Now what do you think? Increasing the sample size, decreasing the confidence level, increasing the confidence level, decreasing the standard deviation. See, we are talking about confidence level, so let's stick to this. Decreasing or increasing? See, if you increase the range, then you can be more confident, like 99% confident, 98% confident, because it is a so big range, so automatically it will represent the true mean. It will hold the true mean. Okay, here the population parameter will lie, so your confidence level will be increased. What happens to margin of error when the sample size increases? See, margin of error, you can see this is error. Error will always be reduced, right? It will decrease. But what is the formula of margin of error? That is z into sigma by root over of n. Okay, z you know, z score, population standard deviation and sample size. Okay. Now, a 95% confidence interval for a population mean is calculated as 18.2 to 21.8. Which of the following is correct? 95% confidence interval for a population mean is calculated this one. Okay. Population mean is exactly 20. Population mean is never exactly 20. The sample mean is 20. That may be a chance that you got your sample mean as 20, and from this you have applied the formula to calculate this confidence interval, right? There is a 95% chance. Whenever you get this, you can simply remove this. The interval will always contain. That is never true. Okay. So you understand the correct answer is B. The sample mean is 20. Okay, next, which of the following statement is incorrect? Confidence interval account for variability in sample estimates. That is true, because there is a variability in sample estimate. If you take 50 samples, if you take another 50 samples, there may be some changes. That is why we are creating a range. Confidence interval means we are creating a range instead of taking a single number, right? Second, increasing sample size narrows the confidence interval. If you increase your sample size, instead of 50, you take 500, then you will be more correct. So when you are more correct, your range will be reduced. That is also true. Confidence interval provides a range for the sample mean. No, sample mean is calculated. So you get a range for population mean. So this is incorrect. Okay. So this is the right number. These are used in inference statistics. This is also right. Okay. Next question. What does plus minus part here represent? Plus minus part it means population standard deviation. No, that is sigma. Margin of error. Margin of error means I am considering the error which may occur. What distribution do you use when the population standard deviation is unknown? T distribution. Right? Which of the following does not affect the width of confidence interval? Sample size, confidence level, population size, standard deviation. See, sample size affects, because if you increase sample size, your confidence level will be lower. It will be reduced, lower range. So confidence level, population size, exactly. Population size doesn't matter with confidence interval. See, your population is 10,000 or your population is 10 million. Does it really matter? No, it doesn't matter, because you are calculating this from the sample only. So your sample size matters a lot. Okay. Next is standard deviation. Yeah, that is also effects. Okay, standard deviation means the error, right? So it also matters. Okay, so which doesn't matter is population size. Now, what happens to the confidence interval when we increase the confidence interval from 95% to 99%? See, we are increasing the confidence interval. So we want to be more sure. Then what you have to do? You have to increase. Let's say earlier it was 162 to 168. It was 95%. But I want to make it 99%. Then you have to take a bigger range. Then only you can be more sure, right? So this is asked in a different way. So you have to make it wide. Okay. Okay, next question. The margin of error in a confidence interval increases as sample size increases. No, sample size increases, margin of error decreases. Independent on sample size. It depends on sample size. Decreases as sample size increases. Exactly. Same, no. Okay. 95% confidence interval is dash than a 95% interval. 90% confidence interval means, see, 95%, 95%. In 95% you have 162 to 168. So for 90% you want to be less confident. So you can write, let's say 164 to 167. Okay, right? For this you can say 90%. But when you increase your confidence level, you have to make the range bigger. So here we can say we have to make the range narrower. In a confidence interval for the mean, which distribution is used when the population deviation is unknown? See, the same question asked in a different way. If the population standard deviation is not known, you have to use T distribution. This one we will understand later when we will do many MCQs from Z, T, chi-square distribution. Okay, so today our focus was on confidence interval. I hope this is very clear to you. There is a misconception that people think that it is a result. No, it is not a result. It is a method. It is not that 95% chance of lying in the interval, but it is 95% of the intervals would contain the population mean. Okay, so you calculate a range of values instead of a single number, so that you can express your uncertainty and you can keep the margin of error in your mind. Okay, this is a part of inferential statistics. So let's meet in our next video. Bye, happy learning. Hi everyone, welcome back. Today we are going to do MCQs from covariance and correlation. First I will give you a small recap, then we will do the exercise. Okay, now in inferential statistics, if you want to know the relationship between two variables, one is bedroom and another is price. In a location you want to know the price of any flat, but you want to know how they are related to bedrooms. If I increase my bedroom from 2 to 3 to 4, then whether the price will also increase or it will decrease or it will remain same. So what is the relationship between this? That can be calculated by two methods. One is covariance and another is correlation. Okay. Now what is the difference between these two? Covariance tells you whether they are related or not. It will tell you that it is positively related or negatively related or not related at all. But correlation will take you one step ahead. It will tell you how strongly they are related. Maybe for changing a little bit in bedroom from 2 to 3, maybe there is not much difference. Okay, or maybe for changing one bedroom there is a high increase in difference. Anything can happen. That will be told by correlation only. Covariance only tell you that it is increasing. Okay, but correlation will tell you that it is increasing in a greater rate or in a lesser rate. Okay, so you understand that correlation tells you how strongly they are related. Okay, now let's do the MCQs. What does a positive covariance? Positive covariance. From the name you can understand. between two variables. As one increases, the other decreases. No, positive means if one increases, then other will also increase. If bedroom increases, price will also increase. If you study for more number of hours, your result will be good. Okay, your marks will be increased. So if one increases, the other also increases. Fine. What is the range of correlation coefficient? The range of correlation coefficient is -1 to 1. -1 means highly negatively correlated. Right? Correlation tells you how strongly they are connected. -1 completely negatively correlated. -0.8 also kind of strong. -0.5, -0.3 then negatively correlated but not strongly. Okay, you understand the difference. Same way, if it is +1, positively correlated, highly positively correlated. If it is 0.5, then positively correlated but kind of neutral. But if it is 0.2, then positively correlated but very weak. Okay, you understand what is the difference between coefficient and correlation. Okay, now what is the main difference between covariance and correlation? Covariance standardized, nothing like that. Fixed scale, nothing like that. Correlation is standardized covariance, exactly. So what is the formula for correlation? Correlation formula is covariance divided by standard deviation of one variable, standard deviation of another variable. Okay, so we can say standardized covariance means this is correlation. This is the formula. Okay. Now what does a correlation coefficient of -0.85? Just now we have discussed. You can see minus means negative. Now see 0.85. So we can say this is strongly negative. Okay. If the covariance between x and y is 0, which of the following is true? 0 means no relationship. No, not related, they are neutral, right? Which of the following values represent strongest? See, -9.90, yeah, kind of strongest because it is near to 1. If it is near to 1, then it is positively. If it is near to -1, then it is negatively. But they are strongest. 0.75, 0.60, 0.40. Strongest is this one. Okay, you have to compare with others. If all the data points lie perfectly on a straight upward sloping line, see, like this. If it is bedroom, and it is price, and this is straight upward sloping line. So here 2 bedroom, 3 bedroom, 4 bedroom. See, this is the price, maybe 1 lakh, here 2, here 3. So you can understand as it is increasing, it is also increasing. So you can easily say they are very much correlated and they are strongly correlated. So we can say this is 1. Okay. Positively strongly correlated. In which of the following cases is covariance most difficult to interpret? Okay, see, covariance is difficult to interpret when units of measurements are different. What happens to the correlation if you multiply all values of x and y by positive constant? See, it will stay same because for correlation it is covariance divided by sigma x into sigma y. So now what you are doing all values of x and all values of y. So these values are just added by some positive constant. So does it really matter to the correlation? No, because you are adding with some positive constant, right? See that here there is no unitless. That is the main difference between covariance and correlation. Covariance has unit, correlation doesn't have unit, unitless. Okay, that is also one advantage of correlation. Now, given two data sets, this is x, this is y. What can you say about covariance between x and y? See 1, 2, 3, 4, 5. Just plot if you have confusion. 1, 2, 3, 4, 5. Okay, but why 5, 4, 3, 2, 1? See 1, 2, 3, 4, 5. But for x1, y5. So x1, y5 like this. x2, y4. x2, y4. This. 3, 3. Here. x4, y2. So x4 but y2. So here. x5, y1. So x5 but y1. So see. This way it is decreasing. So we can say it is negative. Okay. Now covariance unit, suppose the units of x are in kilogram, y are in meter. So what will be the unit? a kilogram meter. Okay, that is the problem of covariance. It is okay, covariance has units. Now, two variables x and y have the following values. What is the sample covariance? They are telling you to calculate covariance. Okay, so let's learn what is covariance. See, the formula of covariance is 1 by n minus 1 summation of I equal to 1 to n xi minus x bar into yi minus y bar. Okay. Okay, now let's calculate this. So x and y. X 2, 4, 6, 8. Y 5, 10, 15, 20. Okay, so y is 5, 10, 15, 20. Now see the formula. You have to calculate x bar, y bar. So I can write x bar, y bar. X bar means the mean value of x. 2 plus 4 plus 6 plus 8. So 6, 12, 20 divided by 4. So this is 5. So let's write this as 5. Now 5, 10, 15, 30, 50 divided by 4. So it will be 5, 10, 15, 30 divided by 4. 12.5. So let's write 12.5, 12.5, 12.5. Okay. Now we have to calculate xi minus x bar. Okay. And yi minus y bar. So for xi minus x bar, xi means every value of x. 2. So 2 minus 5. So it will be minus 3. 4 minus 5 minus 1. 6 minus 5 1. 8 minus 5 3. For yi minus y bar, so this value and this value. 5 minus 12.5. So it will be minus 7.5. 10 12.5 minus 2.5. 15 12.5. So it is 2.5. 20 12.5. So this is 7.5. Fine. Now you have to multiply them. So xi minus x bar into yi minus y bar. See, minus 3 into minus 7.5. So it will be 22.5. This will be 2.5. 1 into 2.5 same 2.5. 3 into 7.5 22.5. Fine. Now we have to put the formula. So 1 divided by n minus 1. Here n minus 1 means total we have 4. So 4 minus 1 equals to 3. Okay, so we can write covariance of x comma y equals to 1 divided by n minus 1. See the formula once again. This is the formula 1 divided by n minus 1 into whatever our value is. So here we have to add all the numbers. 22.5 plus 22.5, 44, 45 plus 5. So this is 50. Right. So now we can write 50 divided by 3. So whatever 16.66, 16.67. Okay. Okay. So let's understand how we have calculated. This is the formula. We have just calculated x bar, y bar, x minus x bar, y minus y bar. We have multiplied them. 1 by n minus 1. We have put the formula. Perfect. This is how you can calculate covariance. Okay. Now let's do it to calculate correlation also with same data. 2, 4, 6, 8, 5, 10, 15, 20. Now what is the formula for correlation? Correlation formula is covariance of x and y divided by sigma x into sigma y. So this one we have already calculated. This is 16.67. Now we have to calculate sigma x and sigma y. So sigma x equals to root over of 1 by n minus 1 x I minus x bar whole square. Okay, same way sigma y equals to root over of 1 by n minus 1 into yi minus y bar whole square. Calculate sigma x and sigma y. See, x, y, x bar, y bar. Same way we write 2, 4, 6, 8, 5, 10, 15, 20. X bar we know 5 over 12.5. Same thing. So we are not calculating. This is 12.5. Fine. Now we have to calculate xi minus x bar. So xi minus x bar whole square. Okay, so whatever value we have to square also. 2 minus 5 minus 3, if you square it will be 9. 4 minus 5 minus 1 square 1. 6 minus 5 1 square 1. 8 minus 5 3 square 9. Fine. Same way yi minus y bar whole square. Yi 5 minus 12.5, that is minus 7.5. So 7.5 into 7.5, you know how to multiply this kind of number, same number, then 25 will always come at the end, and 7 will be increased by 1, that is 8. So now you can multiply 8 into 7, that is 56. So this is a trick by which we can calculate these types of multiplication. So whatever, it is 56.25. Okay, for this it is 6.25, 15 same 6.25, and again same 56.25. So you have to add all those numbers. 56 plus 56, 112.5. Now 6.25 and 6.25, 1250. So this is 1250. So 4, 5 to 1 to 5. Okay, so that is 1 to 5. Now 1 to 5 divided by 1 by n minus 1. So sigma x equals to root over of 1 by n minus 1 means 3 into total calculation 18, 20. So 20. Okay. And for sigma y, this is root over of 1 by 3 into 125. Fine. So this is 6, root over of 6 around 2 point something, and here 40, so 6 point something. Okay, so we have got sigma x and sigma y. Now you have to put in the formula. The formula is divided by sigma x. What is the value of sigma x? 2, 6. Okay, 2 point something into 6 point something. Now you have to calculate what is correlation. Okay, clear. Now see why correlation is unitless but covariance has an unit. See, for formula covariance you have 1 by n minus 1 and this value. So if we just write the complete formula, correlation equals to covariance divided by sigma x into sigma y, right? Now, okay, so formula of covariance 1 by n minus 1 sigma I equal to 1 to n xi minus x bar yi minus y bar. Fine. Divided by sigma x into sigma y. See, root over of 1 minus n into xi minus x bar square. Again, root over of 1 minus n, 1 by n minus 1 yi minus yi square. So if I calculate, if I multiply them, then it will become 1 by n minus 1 into root over of x minus x bar square y minus y bar square, right? So here also in numerator also we have 1 by n minus 1, here also we have 1 by n minus 1. So this will be simply removed. Okay. Here also xi minus x bar into yi minus y bar, and here also xi minus x bar square root over of that. So whatever the unit is, that is completely cut out. That is why correlation is unitless. Fine. So let's recap the whole thing. To know the relationship between two variables, we have to use any of this method, either covariance or correlation. Now covariance tells you whether they are related or not, but correlation also tells you how strongly they are related. Correlation coefficient can be from -1 to +1. +1 means highly positively correlated. -1 means highly negatively correlated. Formula for covariance is this one, and formula for correlation is bit different. So that is why in correlation the unit is removed. Okay, so that's it from these topics. So meet in our next class. Bye. Happy learning. Hi everyone. Welcome back. Today we are going to discuss some MCQs from regression. First, let me give you a small recap, then we will do the MCQ. What is regression? Regression is used to find the relationship between two variables and to make predictions. Let's say you have bedrooms. From bedrooms, you want to know what will be the price of the flat. Okay, so two variables, one is bedroom and one is price of the flat. Now you want to know if the bedroom size is 2, then what will be the price? If the bedroom size is 3, what will be the price? If it is 4, then what will be the price? So simply from regression you can find their relationship and you can make predictions. Clear? This is the simple concept of regression. Now, it can be simple linear regression, it can be multiple linear regression. Simple linear regression means you have only bedrooms and from this you are trying to predict the price. But for multiple, you have bedroom, you have location, you have size, you have color and all these very different kinds of variables. Then it is called multiple linear regression. Okay, now let's start the questions, then we will discuss more. So what is the primary purpose? To predict a dependent variable based on one or more independent variables. These are independent variables and price is the dependent variable because price is depending on these variables. Okay. Second question. In simple linear regression, what is the relationship? See, y equal to a plus bx. Y is price here, that is dependent on what? On them. X is independent variable. So x can be anything like it can be bedroom, it can be size, it can be anything. Okay. B is the slope here and A is the intercept. Okay. So if I draw like this, then it will be like this. This is the intercept, this is the slope of the line and this is x, which can be bedroom or anything. This is y, this is price. Okay, this is the regression equation for simple linear regression. For multiple linear regression, then it will have multiple, let's say b0 x1, b0 x2. So here x1 is the bedroom, x2 is the color. If you add b0 x3, this is the location. Okay, A is the intercept, Y is the price. Simple. This is simple linear regression, this is multiple linear regression. Clear? Now, in linear regression, the dependent variable is also known as response variable. What does the slope equation represent? What is slope? What is B? Simply, let's say if I draw this line, this means if I change x from x1 to x2, from x1 to x2. Then what is the change in y? Earlier it was y1 when it was x1. When it is x2, it is y2. So the change in y due to change in x is called slope. Okay. But when it's like change in y due to change in 1 unit of x, then it is called slope. This is the definition of slope. Okay. So you can explain that for changing this much in x, there will be this much of change in y. Okay. So the change in y for unit change in x. Now, if all the residuals in a regression model are 0, see all the residuals are 0. So let me draw something. Let's say these are your data points. Okay. Now what you have done? You have drawn a line like this. Now see, what is residual? Residual means you have predicted something and something in actual. What is your prediction? This is your prediction. This is the prediction, or we can say this is the regression line. So you have predicted this and in reality also this one. So there is no error. So very good. Error is 0 here. But for this data point, this is the real data point, but what is your prediction? Your prediction is somewhere here. So there is a difference between real and prediction. So there is an error. So this error, let's say E1. For this point, error E2. For this point, error E3. Error E4. So the difference between the real and the actual is called the error. And when you add all the error, then you get total sum of residuals. Okay, so the error is the residual here. Now our question is, all the residuals are 0. All the residuals are 0. When the residuals are 0? For this point, for this point, for this point. So all the residuals are 0 means all the points are lying on the regression line only, right? That is why all the residuals are 0. So you can say that the model perfectly fits the data because your model has predicted this one. And if all the real values are lying on this one only, then your model is simply perfect. So we can write the predictions perfectly fit the data. Fine. Now next question. What does a high R squared indicate? See, what is R square? R square is a value, or we can say that it is a number that shows how well a model explains the data. Okay, if R square is 1, that means the model explains 100% of the variation. But if the R square is 0, that means the model explains none of the variation. Okay. But if it is between 0 to 1, 0.75, that means the model explains 75% of the variation. 0.25, the model explains 25% of the variation. Okay. So R square is a number that will help you to say how well a model explains the data. Okay. And there is a formula to calculate it. Now the question is, then why adjusted R square? Now the problem with the R square is R square always increases even when you add more predictors which are unnecessary. Let's say you have predictor bedroom and size and you have calculated what is the R square for a model, let's say model 1. So it has given you R square 0.70. Fine. Now what happens? You increase bedroom, you increase the number of variables, bedroom, size, color also. Now maybe in reality color doesn't matter that much. But what your R square does, it will be increased. It will make 0.73 for second model. So problem is that here you have added some unnecessary columns. Okay, complexity of the model has been increased. But your R square is improving. So you will think that this model is better. But in reality this model is not better because you don't need this to calculate. Unnecessary you are creating complex. So your R square is unable to tell you that. R square always increases whenever you add some variable. It may be important or it may be not so important. Now to solve this problem, one concept came that is called adjusted R square. For adjusted R square, if it is 0.68, for model 2 it will become 0.65. So it will be able to explain that you have added something which is not necessary, which is not useful at all. Okay, clear? So the difference is that R square cannot tell you whether the extra added value is important or not, but adjusted R square can tell you that the extra added column is important or not so important. Okay, so that is why we try to calculate adjusted R square. Now let's solve the question. What does a high R squared value indicate? High R squared value indicate means a large proportion of variance in Y is explained by X. Okay. What is adjusted R square adjust for? It adjusts for skewness of data? No, the number of predictors in the model. Exactly. Okay. Now if adding more variables to a multiple regression model increases R square but not adjusted R square, what does this indicate? We have just discussed, that means that is not so important. So we can say the new variables improve. No, the new variables are not useful exactly because it is not increased. R square has increased but not adjusted R square. So we can say this is not useful because R square will always increase but adjusted R square will tell you whether it is important or not. What is linearity assumption? Linearity assumption means Y always changes linearly with X. There are many assumptions while using this regression model. One of them is linearity. Okay. There is a change, linear change of Y while changing in X. Now, violating the independence of error assumption can lead to underestimated standard error. That means every error will be independent. See, if your data points is like that and it is your prediction, this error doesn't vary this error. Or I can say that if you are trying to predict the bus delays of every day of the week, so the residuals from Monday should not affect the residuals for Tuesday. Okay, the reason will not be similar. Fine. So we can say that this is called independence of error. This is also an assumption. That means assumption means that if this condition satisfies, then only you can apply the regression model. Okay. Now, which of the following is an assumption of linear regression? Residuals are correlated with predictors. Residuals have constant variance, that is homoscedasticity. Okay. So what does homoscedasticity means? Homoscedasticity means residuals have constant variance across all level of predictions. Okay. Residuals means actual value minus predicted value, and constant variance means the spread or the scatter of residual stays the same no matter what the input variable is. Okay. So the size of the prediction error does not change as the input variable changes. Clear? Simply means that it will look like random scatter. No pattern, no funnels, no fans, nothing. Okay, just random. Next question. In multiple linear regression, multicollinearity occurs when the dependent variable is categorical, nothing like that. Independent variables are highly correlated with each other. Exactly. See, if there are two variables, let's say bedrooms, size, color, price. If there are these variables. Now the thing is that bedrooms and size are dependent on each other. If I increase the number of bedrooms, automatically size will also be increased. So it is depending on this. So if there are dependents in this independent variable, then the multicollinearity occurs. Okay. So independent variables, if are highly correlated, then multicollinearity occurs, and it also cannot be applied for applying linear regression model. Now next question. Which of the following would not violate the assumption of linear regression? See, assumptions are linearity, second independence of error, one error should not be dependent on other, third homoscedasticity, that is the spread of residuals should be equal, sorry for the spelling, homoscedasticity. Okay. 4. Normality of residuals. That means residuals should be normally distributed. It should be a bell-shaped curve. Residuals. Okay. And no multicollinearity. That means independent variables should not be dependent on each other. Okay. That should not be highly correlated. Fine. So from here you can say that homoscedasticity. Now in simple linear regression, how many independent? I have told you only one. For multiple, more than one. Which method is commonly used to estimate the parameters? That is least square method. In correlation coefficient between x and y 0.95. Then what can we say about this one? We did in our last class. There is a strong linear relationship. Okay. So we have understood what is simple linear regression, what is multiple linear regression, and what is R square, and why adjusted R square is used. Okay, so bye for the day. Meet in our next class. Till then, bye. Happy learning. Hi everyone, welcome back. Today we are going to discuss questions from hypothesis testing. But before that, let me give you a small recap. See, what is hypothesis testing? Hypothesis testing is used to draw conclusion from a population based on sample data. That means from your sample data, you draw a conclusion about a population. That is done by hypothesis testing. Okay, now what are the steps? First, you have to state the hypothesis. You have to clearly define two hypotheses, null hypothesis, alternative hypothesis. Null hypothesis means there is no effect, no change, no difference. Alternative means there is a significant difference. Okay, see this example, drug effectiveness. There is a new drug and you want to know whether this new drug improve recovery time for patients or not. Okay, so what is null hypothesis here? Null hypothesis is drug has no effect, no change, no significant difference. Right? Alternative hypothesis is the drug reduces recovery time. There is a significant difference. Okay. So this is your question, whether the new drug improves recovery time or not. Defined what is null hypothesis and what is alternative hypothesis. Once this is done, second step is setting the significance level. Significance level denoted by alpha, it means that this is a cutoff you choose to decide if your result is strong enough to trust or not. Okay, that means it is a chance you might wrongly say something is happening when nothing has changed. This is the risk. See, 0.05, that means 5% risk of being wrong. Okay, 0.01, that means 1% risk. That means you don't want to take risk too much. So you are becoming too strict. Okay, 0.10 means 10% risk. 10% risk means you are becoming quite lenient. Okay, so you understand? It's on you what you set your significance level. Generally these are set. Okay, now once this is done, now you have to choose which test you will apply. Okay, there are different types of test. If your data is categorical, you have to choose chi-square. If you compare the means, then you have to go for ANOVA. If your population standard deviation is known and sample size is greater than 30, you will go for G-test. If population standard deviation is not known and sample size is less than 30, then you will go for T-test. Okay. So depending on your sample size, sample type, you decide which will be your appropriate test. Once that is done, then you calculate and you find the critical value or P value. Okay. From the table, you have to calculate. For one tail test, it will be 1 minus area. For two tail, 2 into 1 minus. Okay. Now, once these are all done, then you check if your P value is less than alpha or greater than alpha. Alpha is significance level. See, this one. This is the risk you are taking. Okay, so after calculating the p-value, you will compare with this. If this is less than, then you have to say that the result is statistically significant. That means you reject the null hypothesis. So you will say that the drug has reduced recovery time. Okay, but if p-value is greater than alpha, then you will say there is no strong evidence against A0. So I cannot say whether the drug has improved or not. So we do not reject the null hypothesis. Okay. We always say we do not reject. We never say that we accept the alternative hypothesis. No. We want to say that we don't have that much of result that we say the null hypothesis is wrong. Okay. So we fail to reject. Fine. So this is all about hypothesis testing. Now let's do the questions. So what is the primary purpose of hypothesis testing? To make inferences about a population based on sample data. Okay. So from the sample data you are just trying to make some inferences about the population. You have taken some samples of the new drugs applied on patients, and from here you want to check whether the drug has reduced recovery time or not. Fine. Now what is the first step? First step is null hypothesis and alternative hypothesis. What is null hypothesis? Null hypothesis means no effect, no difference. What is alternative hypothesis? That means same as no. What we test for evidence exactly. Okay. After defining the hypothesis, what is the next step? After defining, choose the level of significance. Second step. Okay. Now, what do you obtain after, what do you do after setting the significance level in hypothesis testing? So, what is the third step? You have to choose the appropriate test. So, select the appropriate test and compute the test statistic. What is done after that? After that, see, statistic is not done, then you calculate the p-value. So, what is the option here? Compare p-value or test statistic to critical value. Okay. What is the final step? The final step is making any conclusion based on the test result. Now, see which one is the correct sequence. From hypothesis, analyze data, set alpha. No, analyze data will not come in between. From hypothesis, set alpha, compute statistic, decision, conclusion. Exactly. Compute test, no. First you have to do the hypothesis. Collect data is fine, but make decision, no. Okay. What does it mean if we fail to reject null hypothesis? We fail to reject means we don't have enough evidence, right? So there is insufficient evidence to support the alternative. We don't have evidence that we support the alternative. Now, which is a type 1 error? Two types of error happens. One is type 1 error, another is type 2 error. So in type 1 error means that rejecting true null hypothesis. That means that we wrongly reject a true null hypothesis. The null hypothesis is true. Okay. That means in reality the drug has no effect, but we are taking a decision that the drug has effect. So we are considering that the alternative hypothesis is true. So that's an error. This type of error is called type 1 error. Okay, when your null hypothesis is true but you are wrongly rejecting that. What is type 2 error? Exactly opposite. Failing to reject a false null hypothesis. When the null hypothesis is false but we have failed to reject it. We have said that there is no strong evidence against null hypothesis. That is also an error because actually the alternative hypothesis is true, but we are considering that the null hypothesis is true because we don't have enough evidence. So that is also an error, and that error is considered as type 2 error. Okay. The next question is, what is the significance level alpha typically set at? 0.01, 0.05, 0.10, all of the above. Okay. Now if p value is less than alpha, then see, you reject null hypothesis. Reject the null hypothesis. Okay. Now, what is the p-value represent? P-value means how likely it is that the results you are seeing happened just by chance. So, the probability of obtaining the observed result under null hypothesis. Okay. So, we have done the basic questions from hypothesis testing. Let's meet in our next class. Till then, bye. Happy learning. Hi everyone, welcome back. Today we are going to do MCQ from one-tail test and two-tail test in hypothesis testing. First, let me give you a small recap. See, one-tail test means you are just checking that your sample statistic is significantly greater than or less than the population parameter in one direction only. See, you are just checking one direction. Here you are checking left direction. It may be right direction also, but not both together. Just take an example. Let's say you have discovered a new drug and you just want to check whether the new drug reduces recovery time or not. Okay, so you are just checking whether it reduces or not. You are not checking whether it is increasing or not. Okay, so only one part. And this is, you can see, this is a normal distribution. And this green region is the acceptance region. And this red region is called critical region or rejection region. So once you set your hypothesis, null hypothesis, alternative hypothesis, then in second step you take significance level, and from that you calculate what is the critical Z value. See here, the critical Z value is 1.64, the black one. So this one is critical value. If your calculated test statistic, here the calculated Z is -2. So if your calculated test statistic lies in this region, in this red region, then you have to reject null hypothesis. Right? Same way you can do it for right side also. But the main point is you are considering for one side. That is why one-tail test. Clear? Now what about two-tail test? Simple thing, you are checking both the region. This is the acceptance region, but see, this is the critical Z. This is plus 1.96 and minus 1.96. See, this one. Plus 1.96 minus 1.96. Okay. So if your calculated value lies here or here, then you reject null hypothesis. But if it lies here, then you do not reject it. Okay. So in this case, we are checking both the side. Here also, here also. Example, let's say you are giving a training to some students and you want to say whether this training method is improving their average score or not improving their average score. So you are checking both the side. Let's say you are applying a teaching method on a group of students. Now you want to say whether this teaching method is improving their score or it is decreasing their score. I mean, if their average score is 85. Now you want to check whether it is increasing or decreasing. Simply we can write not equal to 85. So you have to check both sides. This one also, this one also. Then you have to go for two-tail test. Okay. See here the calculated Z is lying here. So we can say that we accept null hypothesis. Okay, so now let's do the MCQ. So what is the main purpose of one-tail test? Main purpose is to test if it is equal to specific value. No, we are never checking specific value. Is greater than or less than a specific value in one direction exactly. So it may be here or it may be here also. Both cases this is one-tail test. Okay, when would you use one-tailed instead of two-tailed? When? When you have no prior hypothesis, no, there should be hypothesis all time. When you are only interested in detecting an effect in one direction, exactly. Now, in one-tailed test, where is the critical region? Critical region, I have told you, this is the critical region, right? So, in one test, where? Split equally in both, that is for two-tailed. Entirely in one tail, exactly. At the center, no. There is no critical, no. Critical region will be there. What is the main purpose of two-tailed test? To test if it is different from a specific value in either direction. Exactly. To test if it is greater than a specific value, then it will go for one-tailed. Less than one-tailed, no effect. No. When is a two-tailed test appropriate? When the direction is unknown or you want to test for any difference. Exactly. I want to know whether the teaching method improves the score or not. So that case you will go for two-tailed test. If in two-tailed test, where are the critical regions located? In the both side. See, the both tail. So at the center, no, entirely in one tail, no, split equally in both tail. Okay. What happens if the test statistic falls in either tail in a two-tailed test? Then you reject the null hypothesis. They want to say this is your normal curve, this is critical region, this is critical region. They say the test statistic like Z, T, chi-square, ANOVA, whatever it is falling in one tail, either tail. Here also it may fall, here also it may fall. If it falls in any side but in the critical region, you will simply reject. That is the acceptance region. And this portion is rejection. If it is here, reject. If it is here, reject. This is the critical point. These are the critical region. Okay, so we have understood. This is a very simple topic. So meet in our next class. Bye. Happy learning. Hi everyone, welcome back. Today we are going to do MCQs to understand how to choose appropriate test statistic. Okay, but before doing the MCQ, let me give you a small recap. See, you can choose chi-square, ANOVA, G-test and different types of t-test. But when to choose which one? That depends on your sample data. If your sample data is categorical, then you will go for chi-square test. If you are comparing means of three different kinds of samples, then in that case you have to use ANOVA. Or let's say you are comparing proportions like 30%, 50%. In that case you have to select G-test. But if you are comparing means and you know the population standard deviation and your sample size is greater than 30, if this condition satisfies, then also you do G-test for means. Okay. But if your population deviation is not known and your sample size is less than 30, then you have to go for t-test. Now t-test is of many types. One sample, independent sample, paired sample. So one sample t-test is when you are comparing sample mean with a known population mean. Okay, then that case one sample t-test. But let's say you compare two means of two independent groups, two different kinds of samples and you want to compare their means. That case you have to use independent samples t-test. Clear? But if you are comparing before and after data, like same sample but before and after, it's like let's say a group of students and you have provided them a training. So you want to compare their performance before training and after training. In that scenario you have to use paired sample t-test. Okay, so these are the type of test you can perform while doing hypothesis testing. Now we are not going to discuss the test in details, but which one to choose when, that we have understood. Okay, now let's do the MCQs. So which test is appropriate for comparing means of two independent samples? See, two independent sample. See, two independent group independent samples t-test. Okay, so we'll go for this. If you want to compare the average score of students before and after a training program. See, I told you same sample but before and after case. In that scenario, you will go for paired sample t-test, right? So, paired sample t-test. If you are comparing the proportion of vaccinated individuals between two cities, see the word proportion. Whenever there is a proportion, that means G test for proportions. Okay. A researcher wants to test if the mean income of a sample differs from the known national average. See, known national average means they want to say population mean. So you have two data. One is sample mean, another is population mean. See, in that case, you compare a sample mean with a known population mean. So one sample t-test. Fine. You want to compare mean cholesterol level among three different diet plans. Okay. Three types of diet plan and you want to compare their mean cholesterol level. See, comparing means of three or more groups. Go for ANOVA. A data analyst is comparing the average sales between two different stores. The sample size small, less than 30. Less than 30 means it is not satisfying central limit theorem. I hope you know central limit theorem, you have to be greater than 30. Then what happens? If the sample size is greater than 30, then it behaves like normal distribution. That is the concept of central limit theorem. Anyway, here the sample size is less than 30 and population variance is unknown. See, the population variance is unknown and the sample size is less than 30. Okay, so you have to go for t-test. And now in t-test, which one? See, you are comparing average sales of two different stores. So in t-test, you have to compare two independent groups. So independent sample t-test. This one. Clear? Now you are analyzing gender versus preferred payment card. See, gender is a categorical data, payment card is a categorical data. So for categorical, no problem, chi-square. Go for chi-square. Which test is most appropriate when comparing the mean of one sample to a known population mean? See, one sample that is small, less than 30 to a known population mean. Whenever it is less than 30, you go for t-test. Now, which one among t-test? To a known population mean. See, sample mean with a known population mean. So, I will write one sample t-test. Okay. Now, a medical study compares before and after blood pressure reading for same patients. Before and after case, paired sample t-test. Okay. Now, if you are comparing two independent group means and population standard deviation is known. See, known and greater than 30. So, it will go for G test for means. Okay, G test is two types, for proportion, for means. Now, you are checking if three teaching methods result in different student performance. What should you use? Three methods, whenever more than two, you will go for ANOVA. Okay. When population variance is unknown, the sample size is small, that means you will go for t-test. When known and sample size is large, you will go for g-test. Which test is best for categorical data? Chi-square. What happens when p-value is 0.03 and alpha? This is p less than alpha, then you reject null hypothesis. Which test is most suitable when your data consists of frequencies or counts of categories? Chi-square. If you are comparing the mean test score of 4 different classrooms, then which one will you use? ANOVA more than 2. The sample size is 50, population deviation known, then you will go for G test. Okay, so to summarize, if your data is categorical, go for chi-square. If it is more than 2 groups, then go for ANOVA. If it is proportions, then you have to go for G test for proportions. But if it is for means and population standard deviation is known and sample size greater than 30, then you will go for G test for means. Okay, and now means but population standard deviation is not known and sample size less than 30, then you will go for t-test. T-test is of three types, right? One is one sample t-test. When you know what is the population mean, you have one sample mean, you have known population mean. Independent t-test. Independent t-test means, independent t-test means if you are comparing two separate means, and one another is paired t-test. Paired t-test means that you are taking one sample but before after strategy. Okay, that's it. Okay, so meet in our next video. Till then, bye. Happy learning. Hi everyone, welcome back. Today we are going to do some numerical based on test statistic. Okay, first question. A company tracks 8 employees productivity. So 8 employees productivity before and after a training program. Same sample, but you are checking before and after a training program. So same sample you are doing before after test, that means you will go for t-test. But which t-test? Paired t-test. Okay. Now let's do a numerical. The mean difference in productivity before and after training is 4.0. Mean difference. And standard deviation of difference is 1.69. N equals to 8 employees. So what is the calculated t value? See, this is the formula. Formula you have to remember. T equal to mean of differences 4.0 divided by standard deviation of differences 1.69. Sample size 8. So root over of 8. Okay. Now you have to use the calculator and you can calculate. Next question. A university compares average GPA of male and female students from two separate classes. N equals to 40 each. Male, female. See, you can see that separate classes, independent samples. So you will go for independent samples t-test. Okay. Now let's say n equal to 40 for both case. Okay. Mean equals to 3.2, standard deviation 0.5. Mean 3.5, standard deviation 0.4. Now you have to calculate t value. For independent t-test, to calculate t value, you have to use this formula. M equals to mean 1 3.2 minus M2 3.5. Right? Divided by root over of S1 square 0.5. So 0.5 whole square by N1 is 40 plus S2 0.4. 0.4 whole square divided by N2, that is 40. Okay, now you can use calculator and solve this. Fine. Next question. A researcher compares pass rates between two cities, city A, city B. Here 120 passed out of 200. And here city B 150 passed out of 250. And you have to compare the pass rates. So you can understand there is a proportion concept. Whenever there is a proportion concept, which one will you use? Z test for proportions. We discussed all these things in our last class. Now let's do the numerical. So for P1, 120 by 200 equals to 0.6 pass rate. P2, 0.6. Same. Now pooled P is 120 plus 150. Total they have passed among 200 and 250. So 200 plus 250 equals to 0.6. Okay. We have got all the things P1, P2, P. Now you have to calculate what is standard error. Standard error formula is this one. Root over P into 1 minus P into 1 by N1 plus 1 by N2. So we can write pooled P 0.6. 1 minus P 1 minus 0.6 into 1 divided by N1. So 1 divided by N1 is 200 sample size. N2 is 250. Now you calculate this, you will get standard error. Okay. Now what is G-score? G-score formula is P1 minus P2 divided by standard error. So here P1 is 0.6 minus P2 is 0.6 and divided by whatever the value we get from here. Right. But 0.6 minus 0.6 equal to 0. So the final value will be 0. Okay. Now next one. A study checks if preference for 3 types of juice is equal among 150 people. So you can see this is a category. I told you for category you have to go for chi-square test. Chi-square test is of 2 types. One is goodness of fit. Another is taste of independence. Right? Goodness of fit when used to check whether the observed frequency fit an expected frequency. So here you have observed frequency and expected frequency. Okay. But taste of independence to check whether two categorical variables are independent or associated. Okay. So you just have to remember this thing, independent or associated. Fine. Now let's do the numerical. For group A 50, for group B 45, for group C 55. These are observed. What is expected? For everyone it is 50 divided by 3. Now you have to calculate chi-square. This is the formula. Observed minus expected whole square divided by expected. So for first group 50. Observed is 50. Expected is also 50. Okay. Square divided by expected. Same observed 45. Expected 50. Square divided by expected 50. Again observed is 55. Expected 50. Square divided by again expected, so 50. So if you add them, then you will get some 0 plus 0.5, so it will get around 1. Okay. Next one. A scientist compares average test scores among 4 teaching methods. So I told you whenever it's greater than 2, you have to go for ANOVA. Okay. Okay, now next do the numerical. 4 teaching methods, n equal to 5 each. Group A 70, 72, 75, 78. So grand mean is 73.75. Okay. Now between group sum of square is 150. Within group sum of square is 100. Degree of freedom between is 3. Degree of freedom within is 16. You have to calculate what is F statistic. Simple formula, you have to calculate mean square between divided by mean square within. Now mean square between equal to sum of square between divided by degree of freedom between. So sum of square between is given 150. Degree of freedom between is 3. So it will be 50. Now mean square within groups. So mean square within equal to sum of square within by degree of freedom within. Sum of square within is 100. Degree of freedom within is 16. So it will be around 6.25. Sorry, 6.25. Okay. Now once you get them, now you can simply write F equal to MS between by mean square within. So mean square between is 50, mean square within is 6.25. Okay. Now you can calculate whatever the values. Okay, now let's do the next one. A nutritionist wants to check if average daily protein intake of adults in a town is significantly different from the recommended 50 gram per day. So she collects a sample of 25 adults. So here see 25, that means less than 30. So you will go for t test. But which one? You have taken one sample of 25 people, so one sample t test. Okay. Now let's do the numerical. See, sample mean is 54. Sample mean is denoted by x bar. Population mean is 50. So this is 50. Sample standard deviation is 5. And sample size is n equal to 25. Now you have to calculate t. So the formula is x minus mu divided by s by root over of n. So sample mean 54 minus population mean 50 divided by standard deviation 5 by root over of sample size 25. 54 minus 50 is 4 divided by 1, so ultimately 4. Okay, got it. Now next, a factory claims that the average lifetime of its bulbs is 1000 hours. Okay, A quality inspector collects a sample of 36 bulbs. Now the population standard deviation is known. See, known means population standard deviation known means you will go for G test and to be 60 hours. Then which is appropriate. And here you are calculating means, so you will go for G test for means. Okay, now let's do the numerical. So sample mean is given, population mean sigma n. So x bar minus mu by sigma by root over of n, same formula. So sample mean 950, population mean 1000, sigma 60 divided by root over of 36. Whatever the answer is. Okay. Next one. A researcher wants to test whether gender and preferences are related among 200 people. Gender preference of tea coffee. Categorical variable. So obviously you have to go for chi-square. Chi-square is of two types. Goodness of fit, taste for independence. I told you to check whether two samples are associated or independent. You have to go for chi-square, taste for independence. Okay. Now let's do the numericals. See, male, tea prefer 30, coffee prefer 50, so total 80. Female 70, 50, total 120. Now 100 people prefer tea, 100 people prefer coffee, total 200. What is the expected frequency for male and tea? See, this is the formula. So you have to use row total into column total by grand total. So male means you have to consider this row. This total is 80. T means this total is 100. So 80 into 100 divided by what is the grand total? That is 200. So the answer is 40. Okay, so we have discussed many questions. First of all, how to understand which statistic to apply, then how to apply the formula. After you calculate this, it will help you to do the hypothesis testing. Okay, so meet in our next class. Till then, bye. Happy learning.